All right, hope the lunch was good. Everybody that ate a potato, you'll go into a coma in about 30 minutes. So we'll be done in 30, so I feel sorry for Andrew who's speaking after us. So moving forward in the eVTOL world, we're going to be talking about urban air mobility from the ground up and talk a little bit about some of the legislative things that are going out there. I'm going to kind of give you a macro view of some of the micro challenges, if you will. So we're going to go into some of those things. So to my left here is Mr. Keith DeBerry from NATA. I'll go ahead and let Keith introduce himself.
Hello, everyone. It's already set in. So Keith DeBerry, I'm the Chief Operating Officer for National Air Transportation Association. And would you indulge me for about 30 seconds?
Be my guest.
So about 8 months ago, I was giving a presentation in DC. It was right after lunch, and you never want to go on right after lunch or right before happy hour, right? You never want to do that. So I'm up on stage, it's just me and the stage, right? And it's right after lunch. We've been talking about 15, 20 minutes. And I noticed this one gentleman in the front row kept weaving and wobbling around, and I thought, oh, he's okay, he'll be okay. As I turned to walk, he fell out of his chair that you're sitting in right now, right on the ground. And I turned around and he's like, he's still groggy and stuff. So I went over and I said, are you okay? You need an ambulance? You need something? You need anything? He goes, no. And then he looks at me and he goes, you're really not that boring. You didn't cause this. And my mic was on and the audience heard it. They were howling. They were howling because of that. So I'm really not that boring. That really traumatized me. Say again? All right, all right. All right, we're going to talk politics.
So I'm Rex Alexander. I'm your MC for the day, but today also giving a presentation on behalf of my company, 5 Alpha, but also Vertical Flight Society, who I work as the infrastructure advisor for, and also collaborate with HAI in this space as well. So if we could go ahead and bring the slides up, we'll go ahead and I'll let Keith kick us off.
Thank you. Nobody follow your chair. That photograph was before COVID, by the way. This is after COVID. So really, one of the things we wanted to talk about is the engineering briefing 105 that Airport's done a great job doing this morning. But there are a couple of things in there that I want to kind of nuance out. So one of the things we talked about is we talked about a performance-based regulation, performance-based rule, performance-based advisory circular. How many people in this room have actually dealt with the Federal Aviation Administration in a performance-based rule? So I've had the luxury of, you raise your hand? Yeah. So a performance-based rule is much different than a prescriptive, which the current advisory circular or draft advisory circular that's coming out is right now. It's very prescriptive, but a performance-based rule says there's many ways to get to good. But guess who's in the eyes of who? Yep, FAA. So one of the reasons that I know a little bit about this is Part 5 rule, SMS, Safety Management System for 121 carriers. It is a performance-based rule. And in that, training for the FAA is very important. And I was delighted to hear that you guys are going to be meeting with Transport Safety Institute to talk about the training. And I would assume that is kind of a scenario-based, performance-based, critical thinking-based training. So that's one of the nuances that I wanted to talk about, because performance-based, there's many ways to good, depending upon what your understanding of the requirements are and actually what the operational environment is. So that's one nuance that I wanted to bring out. And then all of this, you know, maximum takeoff weight 12.5 or less, markings, that's pretty much standard boilerplate language out of the other language and stuff. This is what I really wanted to talk about, and I'd like some engagement on this. We've been asked several times, should this be a guide, the new 105 briefing, should it be a guide? for applicants seeking funding under the Build Back Better framework. So any thought on that? No, this guidance, this engineering briefing 105. I'm getting a lot of questions from our constituents about this. There's a huge vacuum of knowledge currently, good knowledge around AAM, especially around infrastructure. Please.
Sorry. John Daniels, like everybody has heard me today already, Prax Aerospace. Definitely, I think it has to be, because otherwise we've got nothing to build that Build Back Better framework around. And we're going to get a bunch of wasted money. I mean, not that political funding isn't grifted anyway, allegedly.
Right.
But we've got to be careful about that. We have to have some standards to build something sustainable. The bright side is the engineering brief and the standards based on or aligns with, a lot of work went into that. And it is tied to not just one OEM, it's tied to multiple, it's tied to a variety of systems. I think the only failures on it for the engineering brief, the fact it doesn't apply to drones.
So right before lunch, you said something really intriguing, how to draw a nexus between Build Back Better and, UAM, AAM, infrastructure. Could you remember saying?
I do.
Yeah. Could you share that with the group, please?
I would happily. So a lot of the Build Back Better is kind of into sustainable and green energy, right? And as we saw from Electric.aero and other entities, there's a lot to be said for having an integrated microgrid into any vertiport that also supports the ground vehicle charging, right? Because the idea is that somebody has to drive you to the vertiport in order to be a user of the air taxi. By linking all those together, you're actually fulfilling a lot of the DOT mandates from Build Back Better, because you're building out the infrastructure. What you end up doing is you have a ground level infrastructure for the cars, and then you can reinforce building infrastructure up to the top where you have the vertiport, and then run there. And then when you add in some of these smart city critical infrastructure pieces that get into the protected spectrum needed for connected vertiports and the UTM and the other things we talked about today, all that can be funded there when they're not getting funding through the AIP or airport specific Build Back Better fund.
Right. So one of the things that I would ask as an advocacy group for business aviation, we're right in the throes of doing, ask through legislation and FAA reauthorization through legislation. So if you have some ideas, some wants, some desires around that we could help with, we'd be more than happy to have that discussion, because we're right in the throes of that now.
I have a feeling we could fill a few notebooks up real quick.
So one of the things, and I am a little protective of the FAA because I spent 22 years in the FAA as an inspector, and I retired as an executive from the FAA. So I'm a little bit protective. So I always have discussions with the executive team about how can we help our constituents and not hurt the FAA or tie their hands. So I think that's a delicate walk, but I think it's one that's worth, because you never want to step on your partner's shoes. So we're very resonant and cognizant of that. So we want to continue to do that, but we want to have that discussion. So in the next slide, who would have ever thought that politics would have got into this beautiful thing called aviation? I would never. I'm shocked and saddened over that. So So there are a couple of pieces of legislation, and the reason I bring those to your attention, because it requires participation by stakeholders. I mean, anybody that has anything to do with this, they need to be actively engaged in this. And a lot of times the FAA will want our inputs, and the reason they want our inputs is because they have money. Recently, there was a FAA program that spent $25 million on grants for training aviation safety inspectors, aircraft mechanics, pilots, those kinds of things. And they didn't get a lot of participation from OEMs and manufacturers and 135, 145 operators. So I would say the opportunity is there. So this advanced air mobility consolidation and leadership, it's a Senate Bill 516. I would say that it is highly bipartisan. It went through no issues, no problems at all. And this, which we lobby pretty heavy for this, because I believe that the aerospace system needs a strategy, or at least a national strategy. So we lobbied for that, and we wanted to bring all the stakeholders in. So to talk about operations infrastructure, security. TSA security is a huge issue with this that I don't think we've even dipped our toe into that pool yet. So I think we need to start having some conversations. This will force the conversations. And they'll start to talk about, and had a conversation at lunch about the air traffic organization. How much interaction have we seen from the air traffic organization around UAS, UAM, AAM, those kinds of things? I think they're being strategic about that conversation and direction. So within 2 years of law enactment, the group must develop an AAM national strategy, what we're going to do, how we're going to do. So I think that's an important piece of legislation. The other thing is this HR 620, and it is a pilot grant program. It's about $25 million. The least amount of grant you can get is $1 million. The only kicker to that is there's a triggering mechanism in there. It says that the FAA has to certify at least 2 AAM, UAM in order to trigger the funding for infrastructure. And it's very clear in the body of the language. So those are a couple of things that I think is important. Upcoming legislation, I think there's more. And I think there's opportunity depending on this upcoming race, what we can do. Go ahead, please.
Sir, but when you say certified too, are you talking about they have to issue 2 type certificates?
Yes.
Yeah, if you read the fine print, it says that money won't be available until there are 2 aircraft certified, and there's another piece, 2 active operators, meaning Part 135 certificate
So
holders.
at the risk of sounding completely pessimistic, how is that incentivizing? Because if I don't have to worry about people funding you to build it out and scale it,
Right.
then I can happily drag my feet for another 5 years and then do it and then deal with it later.
Yeah, it is. So there are some nuances around the 135 certification. Like Joby, for example, has got a 135, but it's not with a autonomous vehicle or with the AAM or UAM. It's with, fixed wing, aircraft. So I think this is true. Go ahead.
Well, I was going to say, now does that count the ones who do have 135s, even if they're very conditional and restricted using drones already, like, Amazon or Wing or those?
It very well could. I mean,
It sounds like it might already be triggered then, so I guess it depends on how to look at it.
yeah, but
Open for interpretation.
yeah, exactly.
That's bad.
Well, there's wiggle room in it, I guess, huh? So those are a triggering mechanism. I just wanted to bring that to your attention. So in our discussion with our constituents, some things that continue to come up again and again and again is land availability. We talked about briefly about that. So, the people that we represent, they operate in a dense urban core that require a high degree of maneuverability. And as with cell phone towers, before cell phone towers ever become popular, people that knew about that was out actually leasing property. And you can't tell me that people are not doing that now. They're not, looking around trying to find places to put vertiports or heliports. So most heliports are single points of design. I would say that it's a good place to start. You start from the known to go to the unknown. That's what the constituency has come up with. Security continues to be a huge issue. So that is going to have to be tailored. TSA is going to have to be brought in on this. And to my knowledge, I don't think there's been any substantive conversations with that.
We've had a few conversations
Yeah.
of that at the VFS on what's that look like when we start talking air side versus
Right.
ground side. And if I'm moving someone from a vertiport to a secure location,
Right.
Okay, what am I doing at the vertiport for screening?
Great question. Next thing they always come up with, and then I wish they had had the conversation this morning from the gentleman from Australia. So there's going to be a combination of electrical providers, whether it be battery, solar power, various things, because everybody's concerned about the power grid. A couple of weeks ago, I was in San Francisco at Revolution Aero, and they were talking about an electric car charging stations that people are actually stealing the cables, cutting them off and stealing them, and then melting them off and selling the copper out of them. So I thought that was interesting. And then another issue around charging came up is around the compatibility for the different vehicles' charging receptacle. So there's no standard, and I take it that Europe has a a uniform receptacle where they can get charged anything. I think that was part of the legislation from EU.
I'll have to, I'm sure somebody in here would be able to answer that. We'll circle back to that.
So of course, safety, comprehensive policy guidance, regulatory mandates governing vertiport operations speak to VTOL. So those are some of their issues and some of their concerns. And so I've been enlightened, but you know what clarity brings, right? Clarity brings more questions. So I've been enlightened this past couple of days. So thank you.
Borrow your clicker.
Yes, sir.
Thank you, sir. So looking at the infrastructure considerations, I'm not going to get into the engineering brief or design. It's some of the things that we need to think about in figuring out what infrastructure is going to look like. And everything has an impact on the design and the dimension and the footprint, the square footage. So one of the things we asked, and this is one that is out there, is how are these aircraft going to move on the ground? So we talk about helicopters today, they air taxi, they hover taxi, they ground taxi. We also do ground handling. In the future, we're looking at autonomous operations on ground movement. So in that space, when you look at the design guidance for hover taxi versus ground taxi, there's a criteria difference in dimensional status for taxiways, because one is easier than the other and requires more dimensional fudge factor, if you will. If I ground taxi and I move into ground handling, say the aircraft comes and lands on the touchdown liftoff area, shuts down, and I move it, is that safe enough that I can actually shrink my footprint? Maybe I can make my footprint smaller if I do that. Then if I have an autonomous system that actually does it automatically for me, what's that look like and what impact does that have on the overall footprint and the safety? Charging, we've talked quite a bit about. We get into the availability. Most heliports don't have electricity that meets this demand. Several airports don't. What's the grid capacity already? What's the grid health? There's a good analogy. A friend of mine bought a Tesla, went home and found out that the fast charging system that he bought, it's got a 50 amp breaker, wouldn't fit in his 100 amp breaker box. So he had to actually upgrade his breaker box to 200 amp breaker box. Well, while the charger only cost him $550, the upgrade to his house cost $5,000. Now we do that same thing at the grid level. You're looking at the exact same problem. Is now all of a sudden we don't have the capacity. Now we got to upgrade. Who's paying for all that? What's that look like? Storage systems, we talk about ESS, electric storage systems, to augment these downtimes. What do those look like? How big are they? What's the fire safety issues with electric storage systems? The large batteries that we charge during the off peak so that we can use it during high peak. We talked a little bit about physiology and health considerations, and then we talked a little bit about common plugs. 25 feet is about the max that you can get currently with a charging cable. Well, the challenge there is you probably aren't going to be able to put a charger next to a landing and takeoff area because it'll be in the final approach and takeoff area. You're not allowed to have an obstruction there. If it's 50 feet by 50 feet on a touchdown zone and the FADO is 100 by 100, you don't have the room or the length of cable. So that means you're going to have to put in a parking place. A regular heliport doesn't have that. So retrofitting is going to be a real challenge when you start looking at charging. 5 pounds a foot. I have a picture of it here in Ohio looking at one of the charging systems. And I remember picking it up. It's like, wow, this thing is heavy and it's only like 4 feet long. I can imagine what 25 foot of this is like. Right now we're looking at 350 kilowatts for a charger. There is a paper out talking about a megawatt charger. You start talking about 500 kilowatts of charger, and then you want to put in, say, 5 or 10 of those. That's a big deal. That's a substation. And if there's one thing I found that people hate more than heliports, it's substations, not in my backyard. And if you're looking to put in a business case for a vertiport in a location, it takes 2 years to permit a substation, it takes 2 years to build a substation, and most of the parts are on back order by 18 months. It's hard to convince somebody to invest in something when it's a 5-year lead time. Well, I saw that EP Systems actually has developed one and has one, but then again, it's like you get what, 2 charges out of one of those trucks. Now you have to swap it. How many trucks do you need? And how fast does it take to charge the truck? Exactly. So this is a charging system that was at Springfield Beckley Municipal Airport. We had a tour out there. Beta has a test facility. They have this charging system and several others out there. They have a heliport or a vertiport. It was for the Vertical Flight Society's workshop 2 weeks ago, and we did a tour. This is what it looks like. And I remember picking this thing up. It's, wow, this thing is heavy. How do you protect that cable so it doesn't get damaged? And we talked about the commonality of the plug. We looked at aerodynamic considerations. We talk about this for helicopters today. We know what the aerodynamic deficiencies are for airplanes and helicopters. We don't really have any idea yet what all the different types of eVTOLs are capable or not capable of. So we talk about, if you haven't heard the term Higgy and Hoagie, hover in ground effect versus hover out of ground effect power performance. Because once you get away from the ground, it actually takes more power. So when you're landing on a rooftop facility, you're going to have to need more power. What's that look like for these type of aircraft? We have no performance data for that. There's another one called weather stock stability. Best way is like you weather vane into the wind. What's the susceptibility of one of these aircrafts to a crosswind? Helicopter, I can tell you there's several different regions you don't want a wind during landing and slow approaches. And we design infrastructure specifically to be forgiving in those particular areas. We talked a lot about downwash and outwash. That's one that's an unknown. I'll show you a slide on that here in a minute. There were 2 new ones I've learned 2 years ago, fountain effect and suck down effect. We never really dealt with this in the helicopter world. The guys that have learned about it in the testing at NASA and such, the F-35, the 88B Harrier, and depending on how an eVTOL is designed, an eVTOL may, have these issues too. This is disk loading. This is the thing that we went down several rabbit holes on this space. We talked about how much downwash are you going to get. So there's a really good article written by a gentleman by the name of Ray Prouty about rotor wake. And he got in, and this figure on the left is from that article. And when we look at what is the velocity that you're going to see from any particular helicopter. So it's based on 2 specifics. It's based on what's the size of the disk and the weight of the aircraft. As the weight of the aircraft goes up, so too does the velocity. As the disk gets smaller, so too does the velocity get larger. So there in the middle, you see the AH-64 is about 8 pounds per square foot. That's the disk loading. And it's producing somewhere in the neighborhood of about just under 50 miles an hour wind. Now, the V-22 on the other end of that spectrum, it'll produce a hurricane wind about 83 miles an hour. And if you've ever watched the YouTube videos, this picture on the right is the one from the UK where it blew up all the pathway going to the heliport. The heliport didn't get blown away. Actually, a friend of mine took that picture, but it did rip up every ounce of the pathway going there. So it's one of those things. You have to design infrastructure on what downwash, outwash is. I know what that is for a helicopter. We calculate that when we design for the design aircraft. How big is your aircraft? I don't know what it is for an eVTOL. I have talked to one particular vendor, and they did share with me that their rotor disk loading is 15 pounds per square foot. And they're very similar to several out there. So that's right there at about 60 miles an hour wind. That's more than most helicopters. So how do I deal with that? As the disk gets smaller, that number goes up. What's that look like with some of the ones with multiple disks, with smaller disks? I don't know. That's something we have to figure out. Dimensions, the aircraft dimensional criteria. The picture on the top there is out of the heliport design guide. We designed to the design aircraft. So the largest aircraft is going to use it. Rotor diameter and overall length are the 2 primary pieces of the puzzle when we do the calculations. If you add up all the main rotors and add up all the overall lengths of all the helicopters, there's a very, very consistent ratio for a helicopter. It's 1.2. If I take the main rotor, multiply it by 1.2, it's going to be very, very close to what the overall length is. If I take the overall length and multiply it by 0.83, it's going to be extremely close to what the rotor diameter is. Problem is, we looked at that from a mathematical standpoint for eVTOLs as they currently stand, and it's not even close because there's so many different designs and styles and types. So that doesn't play into effect. So we have worked with the FAA, ASTM, several others. We basically use controlling dimension. What's the largest? use that, and then use that to figure out what the dimensions are. But the considerations on dimensions, we also, Robert had talked about static load versus dynamic load. There was this big thing about being able to land on parking garages. And I actually brought that up when I worked for Uber. I said, hey, parking garages are great. However, building code says that a parking garage is required to have 40 PSF for landing or for normal road traffic. But they also say that a heliport needs to have 60 PSF for helicopters. So most parking garages aren't designed to 60 PSF, they're designed to 40. How are you going to compensate for that? So you need to figure that out from a structural load. Ground limit, we talked about a little bit, downwash, outwash, and then the last one is the fire safety. We get into the fire safety. I sit on the chair of NFPA 418. So we're working on this right now. But what type of energy are you using? So is it traditional fuel? Is it electric, battery? Is it a hybrid? Is it both? That makes it even more challenging. Then we get into hydrogen. Is it hybrid? And then what haven't we thought of? What fuel or what energy are you using? There was one, I talked to the guys working in agriculture. So, well, we're using ammonia. Okay, what's that look like? Because that's what they use in a lot of agriculturals. It's ammonia. It's like, okay, cool. I haven't thought of that one yet. What are we doing for first responders training and education? Because now we have these individuals out there that are responding to electric vehicles. What's the equipment that they need? What type of insulation equipment do they need? What type of protocols do they need? Was at the ARF conference. ARF is the Aircraft Rescue and Firefighting. This is a lot of questions they brought up at their annual conference is, what's this look like at an airfield for first responder? What's this look like for the airport's fire department? What additional type of equipment do we need? What kind of training do we need to add to it? And those are all good questions. There's a group out of UK, a gentleman is working on standardization of marking. So this is ISO standard 17884s. If you respond as a first responder to an electric vehicle, be it a car, be it a scooter, be it an aircraft, be it a boat, be it a train or something else, when you respond, are they all the hazards marked in the same way? Do they say the same thing? Are they marked with the same color? That's kind of a big deal because right now, I would say based on what we saw from NFPA, only 50% of the professional firefighters have ever gotten EV emergency training. Out of the volunteers, it's like maybe 10%. So that's one of the big issues when you put all these VTOLs in an urban environment. What's that mean for first responders in that environment? What's that going to cost to augment? Are you going to rely on an ARF at an airport if you have an accident? And if it's off-site accident, it's in the street somewhere, what's that look like? So those are some of the questions that we're grappling with. If you're interested in NFPA, nfpa.org there, I'm always recruiting new people in that space, so just ask me later. But I'll open it up real quick to questions. We don't have a lot of time, but anybody have any specific questions? This is just a couple of things. These are the things that drive the design. These are the things that drive local municipality acceptance and community acceptance too.
When we are talking about aliens, they could be having six rotors, or they could be having 8 of them. I mean, the traditional way as what the energy would be, I mean, the energy trade-offs and the trajectory would be happening on the engine quits off. It will never be anywhere close to what helicopter would be having. So why are we fixing ourselves into this box of off and paddle with safety areas? Because like the off for twin engines is, I mean, the paddle for twin engines is 1D. So do we put it around that point, or do we think something different? And same goes for, I mean, we're talking about this is just one. The other one thing we're talking about is things like fuel. How do you know what kind of fuel is going to be coming in? Like it's going to be hydrocarbon, it's going to be SAF, is going to be gas, like petrol, it's going to be electric. I mean, there's so many other possible dimensions which are coming. And of course, then we come across, and Jonathan also said, we have battery packs and doing it. Standardization, I think the question was posed earlier, yeah, we don't have standardization around the board, septic rules around the batteries. And if you come into the question of Europe, when you close, where's Europe move to? It's only on the mobile phone, so the next year on it's going to be a unified, but I think a whole lot of things depend on the standardization. Another simple, we have a standardization which is driven around this board. I think it's very difficult to get on to doing this. Otherwise, situating ourselves with the knowledge that we have around telecom, designing something for completely new things.
Yeah, I would agree. It's just a challenge. I think, again, I go back to what Robert says, a crawl, walk, run. And when you go in front of a municipality and you say, want to put a vertiport, the first thing they're going to look is what's the standard? The standard is going to have to morph, grow, evolve over time. I don't see the first standard being the end all to be all standard. It will mature over time as we prove that we can do it safely. I know that I've had that discussion with different groups. Well, I've got 8 rotors. If 2 of the motors quit, I'm still capable. Okay, great. You're capable. How many motors do you have to lose before you're not capable? And what happens when everything fails? What are you going to do? So I think we get into that theory and hypothesis of redundancy versus actual safety. Right now, we're being very conservative because we don't have any facts to back anything up. So we're being very conservative. As we gain facts, as we prove that these things are capable of doing what they say they are, I see what you're saying, maturing. It's going to take a while.
Correct. Sorry, but isn't it ties back to the public versus private use? The question about we don't know what fuel's coming only applies if you're open to everybody. If I know exactly what's coming because I own the aircraft and I bought the aircraft and they all have the fuel, whether it's battery, hydrogen, what have you, that I chose, I know exactly what I'm going to need. There's no question. The challenge is if you're trying to do a public-private partnership or a public use airport and generate revenue for a public entity, you have to be able to serve all the people. The same way that now if you build a gas station that only has diesel, you are not going to get the revenue you think you're going to get.
No, and you bring up a lot of good points. I wish, we could go down this rabbit hole all day long. So I don't want to take up the time of our next speaker. But again, any questions you might have, if you have them today, always you can bring them up anytime to me during the day. After this is over, you can reach out to me if you have any questions, you want to get involved with anything. Again, I'd point to these discussions we're having right now within the Vertical Flight Society. We had the workshop 3 weeks ago in Ohio, 2 days of this exact thing, basically getting everybody sitting down and say, okay, what makes sense, and do a full think tank around that and come up with some ideas. So I would encourage you to become as engaged as possible, because we do talk to the FAA a lot and they do listen most of the time. So we have a good relationship there. So. There are some here. We'll actually have a little bit of a presentation tomorrow that I have a panel. You'll actually be able to talk to and ask some of the OEMs some questions. Yeah.
Because they're building it now.
Correct.
What standard are they guessing at future requirement? To me, that's.
They're engaged. No, they are engaged. We can have that discussion tomorrow. I don't want to steal our thunder for tomorrow. I'm going to go ahead and wrap it up with this, and then we'll move on to the next speaker. Thank you. So our next contestant, coming from Washington, D.C. in the FAA, is my good friend Andrew Goldsmith. Andrew works in the FAA Airports Division. He works with us on occasion with the U.S. Helicopter Safety Team. And we have a lot of good discussions in that space. Primarily, what he'll be talking about is data capture, how do we capture this data that is vertiport information, GIS data? How do we catalog that? What is the parameters that we're looking to capture? One of the things we're trying to do is make sure that we have good visibility and we have good integrity of that data. So without any further ado,
Thank you, sir.
all yours.
I'm going to stand at the podium. Part of this presentation is going to be me looking at this screen for the most part, and then half of it will be looking at you, because the first part of this is a lot of the airspace stuff, what we're doing in terms of airspace evaluations of these vertical takeoff and liftoff and takeoff sites. So my name is Drew Goldsmith. I am an aeronautical information specialist from FAA Office of Safety and Standards at headquarters in DC. Our main focus is translating infrastructure policy into data to influence safety in the national airspace system. Been with the FAA for about 20 years, everything from making VFR charts and helicopter charts, all the way through the data capture, verification, validation pieces, to this job here in the Office of Safety and Standards, and interpreting those guidances into data that promotes safety in the NAS. So it's funny, I asked my brother while Rex was speaking, if he's had training on EV fire suppression, and he's a captain at in Howard County, Maryland fire station, and he says, no, we follow the model from FDNY, who brings a dumpster full of water on a flatbed and takes a crane and drops them in a dumpster. So that's their solution, apparently. So could be a joke, I don't know. But anyway, I thought that was kind of interesting because he's right on the forefront of some of the, the fire protection stuff. But so we'll get rolling here. Like I said, I apologize. I might be just reading off PowerPoint. This is not death by PowerPoint, but I want to say appreciate VAST and the team for having us out here. This is our first time really out talking the vertical space a lot. We've done a lot with the flight standards, our ATO counterparts, and the USHST on plussing up a lot of the heliport data and the safety impacts and improving safety around what kind of data can we collect again to promote safety. So that's our focus, obviously, on the eVTOL side as well. Now with Robert having published the EB 105, we've been monitoring that for a couple of years, and we're trying to translate that down into, okay, what kind of data types do we need to publish to the public to ensure safety of flight, et cetera, et cetera. So a lot of this first part of this presentation, like I said, is kind of airspace. You guys have already seen this timeline. The EB is out on the street, and obviously the next step is turning it into an advisory circular and vertiport design ACs and things like that. So this was a slide carryover because obviously it just hit the street last week or Monday, right? Monday, right? I read my date here, Monday. Anyway, so this is kind of an outdated slide, but so from our airspace specialist who's working with the tech center a lot, is Cliff Johnson in the room here? Didn't see Cliff come in. So there's a lot of research around the technologies, as Rex and the team mentioned up here, what goes into the design standards, the guidances, what research steps, the OEMs, things like that, gathering data from them to influence a lot of the design practices and things like that, which you probably heard about or even read about from Robert this morning. So not too much on this slide. I'm assuming these slides are available after the presentation, so you can go back and research what we're doing there, obviously continuing collaboration, et cetera, et cetera. Our interest here a little bit on the airspace and design side is Part 77 and 157 impacts. Basically the first step in notifying the FAA that there's a construction of these facilities coming into somewhere, some plane in the NAS, reviewing the airspace, protecting the airspace from any impacts, and moving on through the data chain here, which I'll get to in a minute. So no problem with Rex cutting into time because this is probably going to be a little short presentation, but that's the kind of stuff we focus on the 120 side of the house. Robert sits on the 110 side of the house, and so we monitor the policies from his group and the pavement engineers, lighting engineers, everything that translates into data. First step is obviously notifying the FAA. So that's the first kind of, how do we interpret 157 to accommodate the vertiport sites and vertipads, right? So we're obviously working at right now and translating into airspace evaluations from our different lines of business, different stakeholders that comment and take action on whether or not, this site is feasible, usable, whether we have any objections to the site, et cetera, et cetera. So we're doing a lot of work around the airspace piece right now. So let you guys read death by PowerPoint, sorry. Obviously, anytime we're constructing a new facility, it starts with the CFR, 14 CFR Part 157, which is our 157 7400 process, which is our 7480 form. And that's for any facility in the NAS that you want to build. It follows that 157 translated into the 7480 process. You can Google FAA 7480 form. You can find the OEAAA.FAA.gov for those aren't familiar with the site. But that's where your first input into the FAA that you desire to build a site, or somebody desires to build a site, right? Right now, I think some of these timelines are a little bit interim standards, like in the middle there. Obviously, there's environmental reviews around this that impact the review, but we're more focused on collecting that information to facilitate the publication of these sites, get them in the NAS and accounted for in the airspace, like I said. So what do we do? What are we working on right now? So some of the, obviously the EB 105 came out. So we're pulling out, features and ideas out of 105. Of course, we've seen the draft for a couple of years now. But we're pulling out what information, like I said, is valuable to ensure the safety of the NAS, right? They're working on the boarding, discharging. You've heard all the security talk, TSA talk kind of stuff. It's kind of outside, a little bit outside my wheelhouse, but we're working with the tech center closely on making sure that we're capturing the most accurate information, so not to harm the public, flying these things around. So ongoing coordination within the agency is we're going to follow the same model we did. We had a 2018 FAA reauthorization, had a section 314 in it, which we had to put some focus on the air ambulance operations, and it really got us looking at private use facilities. Obviously, I know some of this wants public money, public use facilities on some of these vertiports, vertipads, but our focus we worked our issue backwards about why just AAM, why not all these private use facilities. So we actually had a great working group between the USHST folks on the outreach on the external stakeholder side, and then the ATO flight standard side. We really came together and worked the issue backwards, and we're right in the middle of improving workflows, ingestion mechanisms, policies, pieces of paper that we still float around, unfortunately. So we're going to follow the same sort of model on doing that. And our specialist, Dave Carlin, who's not here with me today, is the airspace specialist right now, who's tackling that initial airspace, what that's going to look like, the airspace evaluations, and then helping us define that into, turn that into the actual data points, the features and attributes. That's the data geek. I'm the data geek. So I want the features and the attributes of the facility. So ongoing now with EB 105, kind of solid sign on the street, puts a little more focus on the airspace side up front, and then obviously the data to follow. So some of the groups that he works on is with the EASA and ICAO. Obviously, a lot of involvement, a lot of interest, especially in the EU on some of the vertical entrance stuff. So he sits on a lot of the internal coordination with those two groups. But so what we're doing here in terms of like the data capture is, best available data is always geospatial 3D data. So we're going to develop, we drafted a heliport survey EB, how to survey a heliport, and we're going to develop a vertiport survey EB. It's a long way off, not anytime soon, but Dave's taking a shot at modifying this heliport survey to fit the vertiport infrastructure and things like that. So these drop downs he included in here are kind of what we look for in OEAAA. So when you file that 7480 form and say, hey, I want to build a vertiport or add a vertipad, whatever it is, there's certain things that the lines of business and stakeholders want to look at. Obviously, charging stations, which we just heard is a big deal. Fuel types, things like that is a big deal. So those are kind of the first, there's some interim guidance, internally on what to do when these things come out. So this is what OEAAA looks like. OEAAA right now is the mechanism to go in and start your 7480 process, your notification to the FAA of construction, things like that. So he's pushing hard on the OEAAA side. We work in stovepipes in the FAA, unfortunately, so we don't own that system, but we can influence it, with money. So it's, coming down the pike soon for the airspace specialists out in your regions and ADOs, your local FAA, Office of Airports facilities that will monitor these cases, giving them a little bit of something to look at inside the system that directs them right to a vertiport or vertipad specifically. So that's what he's working on a little bit, but I'm going to quickly pivot over to, where we're collecting all this information. If you haven't been to the Airport Data and Information Portal before, if we're not collecting it, we'll funnel it to you. So I manage this program here. along with a few other AIS SMEs back at headquarters. And it's really a consolidation of different ingestion points from the FAA. The one about OE AAA and 7480, we're actually bringing that into ADIP so that the customer has one kind of FAA.gov domain that they need to focus on, so they don't know, I forgot my login here, I need to log in here, I need to log in there. We're building out the airport data and information portal to be that one-stop shop for all the information that's published from the FAA in terms of data. For those of you that fly, use the different third-party apps to fly around on, or the chart supplements or airport diagrams or anything published by the FAA, all that information that's published there funnel through our site first. Obviously, there's QMS and verification steps built behind a lot of this, but Office of Airports is the front-end collection mechanism on a lot of this data. So we're trying to get those other pipelines that we had to funnel folks to for now back in here. I don't know if anybody's ever experienced OE AAA. Anybody? Okay, shaking the head. We're going to try to make that user experience just a little bit better than what it is today. But so bear with us. That's coming here hopefully winter, if not after the first of the year. But we're working on doing this. So that being said, obviously ingesting the vertipad information into this system in order to collect it. Obviously, public users have access to this site. You don't even need to log in to gather information from the FAA. It's more or less if you're the one submitting information to us about a site, would be the only reason you need an account registration. So everything we publish in the FAA in terms of data is you can find on this site through our various search bars and things like that, and the search is accessible right from the main page there in the graphic. So you can download your 5010 forms. You can download the entire library of data that the FAA has right from that site through advanced search. But just wanted to give you a kind of, if you haven't been in there yet, please poke around. If you feel like you need access, we've actually, in terms of the vertical arena, we've actually given access to a lot of the PEPs and the third-party procedure designers, a lot of the aviation safety inspectors who were never our power users per se, have come in here. So the agency as a whole is coming into the system and influencing work, behind the scenes here. So it's been good for us, especially on the vertical side of the house, to get those power users back in here because they're the ones standing right in the middle of the tee-off most times, right, and can influence data changes on a whim. So it's good to have those users into the system. So obviously geospatial, I live in the geospatial world. I also run the Airport GIS survey program. It's the 18B, AC 18B program for those of you that have ever heard that type of stuff at airports, NIPIAS airports, the funded airports. But we do a lot of visualization tools. We make the tools easy to get the information to the FAA to make a change, to make an edit, a quick edit, send somebody on your behalf. You can work on behalf of the airport operator. Just get us some kind of, we do have a security obviously in place for the FAA DOT, but if you're working on behalf of an airport or facility, all we need is something during your registration that says you're allowed to work on their behalf. It's easy access into the system, and we'll assign you that facility, and you can influence changes at that facility. So, DOT, federal system, obviously coming in, we check every click. So, we don't really have a problem on letting people come in who want to work on behalf of the airport, but we obviously need the messaging from the airport in order to do so. But so this is, some of the work we did with the heliport. On the heliport team in turn, like I said, with our outreach and external stakeholders through USHST, through our ATO and AFS internal stakeholders, we came up with a list of features and attributes at the heliports that they wanted collected to better, plus up that data that I talked about in terms of, safe operations in the NAS. These are just a few we've pulled out. We literally kicked off a meeting 2 months ago, just to try to get the stakeholders back in the same room again and talking on what the public would expect on the vertiport, vertipad side of the house in terms of when we start publishing these things as their own separate facilities or the on-airport sites, coming out onto, in the chart supplements and things like that. This is just a preliminary list. This is, like I said, my colleague Dave Carlin pulling off some of the things we did for the heliport side, what we're going to do with the vertical side, the vertiport, vertipad side here. Obviously not set in stone. I saw some corrections already from the previous slide deck, but so that's just proposed information there. If you can think of anything else, like I said, we work through those external user groups, stakeholders that would influence safety and increase the safety of these sites. Obviously, we're all ears. The FAA is all ears. Like I said, we pulled down as much as we could out of the EB. the airspace work that's being done that I touched on earlier, kind of influencing what we want to collect down and publish downstream. But this is like an initial list coming out of that kind of EB and that work that we did internally with the helipad folks. That's it for me. I know there was some questions that we were asked about earlier that I wanted to open the floor up to. But that's the quick and dirty of what we do in the Office of Airports on the 120 airspace and airport data side. Just making sure we know where these facilities are. We've done a huge cleanup effort in the last few years from the latest reauthorization on ensuring that we have the accurate location of these sites. If you're still flying around and there's still some that are outdated, best way to get it to the FAA is that 7480 process through OEAAA, someday through ADIP. Just let us know. Obviously the drone community's helped us a lot because of the restrictions on some of the airspace with people can't fly because the grass strip is now a storage facility. We've done a lot of that cleanup over the last couple of years, but anything else that can influence safety and help you guys, land and take off in a safe manner would be greatly appreciated, but that's the mechanism there. But quick and dirty, I appreciate it. Rex, turn it over to you for questions.
All right. I've already got one question.
All right.
So are you capturing the 157.1 applicable drone facilities or drone operations? And I ask that specifically simply because that's really all I care about when I talk drone ports is that if they're not intermittent and anybody else would have to file for a facility, why aren't you? And if you're not, do you intend to? And simply because if you look at some of the e-commerce press releases, and every distribution center in the United States will soon have a drone port on top of it, or a nest or hub, or whatever the word of the week to not say drone port is. This becomes a very valid safety problem and potentially a hazard, if not risk, for what we're trying to do here.
Right, and so the nest and hub idea, right, we looked at first. So we have a new division in the Office of Airports, AS 200, the new entrant position. They're actually been tasked, even though they haven't even stood up yet, with looking at that exact problem. So it's come off of my desk per se, because just like Robert had stood up the EB in 105, there's policy in place first before you even talk about the data piece. But the best FAA audience that you need to ask that question to is the aeronautical charting meeting folks. That's a public forum, happens twice a year. That's the mechanism. That's the grassroots mechanism. Because unless we're designing policy around it, we don't do much with the data side of it. But our section is waiting on the nest and hub and those ideas we know are happening today.
Like this, not each other, but if there's a 526 day notice for known activity out of a single point in Arkansas, that is a facility under 7.1, and they need to follow the rules like everybody else. There's no way around that. Once you hit that 1 year operation, 10 operations a day, 3 days a week, you qualify under 7.1. But for whatever reason, they lost, and that's
yeah.
And I'm sorry. Every 4 months I have my clock working outlook, send an email to this the last 5 years for email going, hey, how do we get chartered? Because nobody can actually get chartered without some kind of a special thing. And we find them with all of those. The NSF has them, the KDA has them. They're out there, but there's no policies that can happen. So I appreciate the fun, but no one's actually.
I'm not trying to pun, I'm just saying that's how it is, unfortunately, is that forum drives a lot of times the need for the FAA to actually put some policy behind it. And so obviously our first new entrant policy that's come out is our vertiport EB, right? And so the demand has to come from the public, unfortunately. In that case, we understand that they're out there flying around. We want to make sure, I'm the Office of Safety and Standards, right? Last thing I want to do is to pun it. But right now, the official mechanism to kind of enforce the FAA to get on the bandwagon, and I'm talking outside of my swim lane, by the way. I'm just a data geek, but the aeronautical charting meeting does hold a lot of weight in terms of what they're going to do in that audience, though, is they're going to punt to somewhere else. Well, who they're going to punt to is my executive, John Dermott. So they're going to punt to him, but that is going to enforce us to look at it harder from a policy standpoint and airspace standpoint, because I don't even know if did they file a 157 notice and it's just NOEAAA just sitting there? Okay, so that's where the enforcement comes, lack of enforcement is coming down.
That doesn't count. We would from the first time somebody filed a notice of intent to build a drone port, and that policy letter that sat on, still thinking about it, waiting for UPT, Yon, TESA, name whatever program
Sure.
we happen to build this policy out. And the problem is that you're flying helicopters, and you're flying helicopter routes, and this happened in Nevada, along the most populous route, 2 million passengers a year fly over it. A bunch of knuckleheads put together a drone port thing next to a college, right in the middle of that approach, up to 500 feet. No charter, no notice. They didn't understand how to map. And that's just one example, and then there's many others. No one's acting on it. It's just,
Right.
it's gonna take somebody crashing into one and dying.
Unfortunately, I hope that's not the case. I hope we can get out ahead of it before then. But you're right. I appreciate the feedback there.
I have a follow-up question for that. I hear there's a lot of registered programs. How many safety reports have been registered for that? How many times have you put a safety report into the FAA using a confidential human factors reporting system or whatever the FAA calls it?
The answer don't start with that. And it's being told like, you gotta look at it, I think they're popping up.
Because you can tie them to specific press releases of 4 years accident-free under our exemptions, and then you can sit there and pick out those manufacturers, those aircraft in the asterisk. It's absolutely amazing. I hope someday someone in a FSDO is looking at these things and connecting them to the accidents that are happening.
Other questions?
Hi, Drew. Cat Wright with Elephanters. Do you have an estimated timeline on the LAP 7480 moving over to ADIP? Was that in there and I missed it?
Right. So we hope to go into testing here in the next couple of weeks. And then we're obviously, you said Helipanners, right? Going to be probably those couple of communities be our first set of testers outside of the internal testers. And then we'll test it NAS wide and then we'll release it. Probably, like I said, end of the year, if not right after the first of the year, but testing is right around the corner and it looks pretty good so far. So I know you guys, your folks have been patiently waiting, I know.
Other questions? So one of the things I'm going to follow up with is in looking at moving forward, does your division look to have, say, a safety forum with industry to sit down and look at what are the data fields that we need to be capturing for vertical lift, be it helicopter, be it VTOL, be it UAS? Because in looking at what we have currently on the 7480 forms, the 5010 forms, the airport master record, it's extremely airport centric. So that's one of the things, working with VFS, HAI, USHST, and the VAST was one of the things we want to be involved in. We want to help the FAA drive that narrative and make sure that we're capturing the data that users need.
Right, right. So yeah, I'm actually surprised I haven't gotten any comments about the 5010 form being canceled at the moment, but you can go research the Federal Register. It's coming because it is so airport centric, right? And so what we want to be able to provide out of the program is all of the information that, you know, our teams have worked on with the heliport side, all the new features on the vertiport, but that's why, you know, it's not going to be an internal huddle. It's going to be an external huddle, kind of following the same model. If it comes to an actual formal safety forum, we'd be more than happy to probably set up. It's a good idea. Probably set that up. We're trying to move a little quick in the near term because we know these sites are coming on board, especially if there's going to be public funding on a public use side of these. Obviously, we need to get out ahead of that quicker rather than later because we're going to need that information sooner. And that'll drive the airspace folks to get their act together and get the airspace process figured out down to the data process, and we move out, right? So expect that to ramp up with EB 105 out on the street. All those talks are going to ramp up. Safety forum is a great idea. I will definitely capture that and take it back. Yeah.
So shameless plug for the U.S. Helicopter Safety Team. Our next forum will be in Washington, D.C. in February, the week before Valentine's Day. I was told if I ever did it on Valentine's Day, I would never see the light of day.
And
Yeah, but
so we will be there for sure.
so let's get together after this and get that on the agenda.
Sounds good.
Thanks. Will Williams, GPS Flight Forward. So one thing John said just sparked this thought is that, you know, we've been talking about vertiports and the air taxis and things like that, but I think what John was referring to more was the small UAS. there are a lot of small US, big companies doing small US on a grand scale who are just taking off out of parking lots, from drugstores or Walmarts and things like that. So, how's that gonna, I mean, are you looking at that kind of thing? How are we ever gonna get them?
I mean, the only thing right now
Reined
that
in.
we have from a data standpoint in terms of a filter to our office is the LOAs, right? The certificates to fly right now is the only thing that we can connect to, but we haven't even taken that action yet. So I don't know. That is a little bit above what we do in 120, but we know that right now there is that interest, right? And so the LOAs is pretty much the only thing we may pull into the system just to give kind of a graphical idea of what we're looking at. But in terms of, those pop-ups is as long as, hopefully they're filing, before you fly. I can't even speak for before you fly, but, hopefully they're filing, within regulation.
Well, it's all approved. I mean, but
Yeah.
it can be done on a grand scale without
Yeah.
vertiports. And I think that's kind of the idea for a lot of the companies is to be able to operate in that manner and
Right.
avoid all this.
Right. So pop-up versus a static position?
Not necessarily, no, there's 135 doing it. Yeah.
So, yeah, in talking to Jonathan, one of the things we looked at was, there's a NOTAM, several NOTAMs across the country. There's one specifically out of Arkansas and Pea Ridge that came out. It's over 500 days long, but 60 miles by 30 miles. That's basically Walmart. Problem is, we have no idea where these vehicles are originating or coming back to. And yeah, there's a lot of aviation that actually does occur below 500 feet, no matter what
Oh, yeah.
people say. So that's one of the areas that I think we're looking for assistance in defining what a drone port might be, and then what do we do to capture that data, and how do we make it visible so that the general aviation public knows it's there and can avoid it.
Yeah. And I think, like you said, it's already defined in 157 and the 7480. So it's, I think that's obviously the demand is there, right? The need is there, obviously. That's probably a next step that we should probably think about in 120 back in the office on putting a little more effort around that. Now that the vertiport stuff is kind of going to follow the same model that we did for heliports, I think the drone port stuff is just the next one to follow. Because you're right, we see it all the time. The nests and hubs pop up and things like that. But great interest of mine coming from the data side. But yeah, definitely appreciate the feedback on that. And hopefully, as you develop the USHST, agenda, let's rope in those conversations. We can get some points of contact out in that forum, maybe even the VFS work or other forums that you think could really drive the nail home that we need a better focus on the data capture side of this. Would be greatly appreciated. That's why I'm glad we came out here, because this is a new kind of realm for us. We've been so airport centric for a long time out of the FAA, but obviously Section 314 a couple of years back got us looking at the heliports and things like that. But question in the back here. Oh, sorry, right.
One more, actually kind of a two-parter, and I'm not sure that you're the person to answer them, but I just want to get them out there in the world and make sure people are thinking about it. So number one, well, first, thanks for all the work you've been doing. We appreciate it in the industry. We appreciate that heliports and vertiports don't feel so much like the neglected stepchild anymore.
Not at all.
And along those lines, I know the ADOs and the FSDOs and the various lines of business that review landing area proposals and conduct the airspace studies are busy, and they have a lot of things going on. We see, it's 45 to 90 days, I think, is quoted for study time and not promised by any means. We frequently see it much quicker, and we frequently see it much, much longer. So I'm wondering, with the expectation of influx of heliports moving to vertiports potentially, and having to go through a new landing area proposal process for that, is there any plan in place to beef up those lines of business to add?
So I can't speak for like the FSDO side in terms of like inspecting these sites and the turnaround times there, but I can speak for the Office of Airports putting resources. We're going to put dedicated airspace resources in each service center. So we're actually breaking our own mold of regions and ADOs. So we'll have 3 dedicated responsible airport staffers, is what we call them, in each region, that are focused on the private use facilities, mainly the heliports and obviously the vertipads coming up. So we are putting a resource attention on those needs for quick turnaround. Obviously, moving the landing area proposal process into ADIP allows us to put pressure on the other lines of business who are involved in the process, because it'll be a very transparent in terms of tracking who's got the ownership of the next step, things like that, that we'll be able to put pressure on to move things around. You know, I don't like to play the resource card from the FAA side of the house, but from the Office of Airport standpoint, we are putting resources in each service center to focus directly on those missions there. So a
And
little bit of improvement. We'll see. Time will tell.
second part of that question, I know that the inspectors have been going to the kind of heliport inspection course. Is that going to be amended for vertiport inspection to in alignment with the engineering brief and or the forthcoming vertiport design advisory circular?
So all signs point to yes. I would defer to flight standards, but flight standards is here giving me a nod that yes, it is happening. So that's definitely outside my wheelhouse in terms of the inspection training. But Nolan, you have any comments on that?
Yeah, a couple of things. I'm Nolan Crawford from Flight Standards, as Drew just said. Go back to a couple of things. I want to brag on Drew and Robert and stuff. The program that he was showing up there a few minutes ago is called ADIP, the Air Data Information Portal. That portal has taken the helicopter community out of the airplane-centric thought process. We spent about a year and a half, I guess it was, going through changing stuff. I've actually got it pulled up here in front of me. And we can now put in stuff like ingress, egress. We can now put in all the TLOF, FADO, safety area sizes. We can put in what type of surface is actually there now. We can go in and put the different types of lighting system. I don't see this being any different for the VTOL community once we start pulling that data in. One of the other pages here is more along the lines of services and facilities that are there. So we've already got some of that data structure set for this community when it transfers to the VTOL side. Is it right now set up in ADIP for the VTOL? No, it's not. But we started moving in that direction already from a flight standard / airport side to try to start encompassing that. Another one of those program or teams that I'm part of and actually leading right now is the helicopter modernization team. We are actually changing that team and its mission set, as you will, to include the VTOL community as a whole. So we're already working in that direction. So some of the things Drew is saying, he's being kind of humble on it because his office has actually done a great job at moving some of this stuff forward. Same thing with Robert that's sitting over here. A lot of time and effort went into that EB. And I think that he and his team and Flight Standards and a whole bunch of folks spent a whole lot of time trying to make that the best product it could be with the lack of information we have today.
And having been on the ADIP system, I will say it's very functional. It's very friendly, user friendly. And like you said, you can go on there and download a single location where you can download every landing site in the entire United States into a spreadsheet, data mine it to your heart's content. Everyone that's been submitted.
Yeah, everyone that's published in the FAA, published.
And Kat, one thing that you asked that I failed to answer through that little spill is, yes, we are looking at, I'm one of the instructors for the heliport course, as you well know. We are looking and probably in about 2 weeks, we're teaching another heliport course. Part of that same time frame, we're going to be trying to figure out how do we bring the EB into the course. Are we bringing it in as an add-on initially until it becomes more mature? Or are we going to add it as a standalone course? With budgeting and stuff like that, if I was a betting person, I would probably say it's going to be an add-on into the course until probably the AC or something of that nature comes out. That way it's more mature. We got some more data on the vehicles that will be coming out and stuff like that. But again, that's a guess right now on my part, and it's definitely not an FAA standpoint on that. But we are in those discussions as we speak.
Any other questions? One thing, Drew, is the OE AAA going to go away completely and be absorbed by the ADIP?
No, I mean, there's obviously the obstacle side of it. There's also the ALP update process that ARP's involved with. We may look at moving that down. Basically, want to provide obviously that one-stop ingestion, but also for our own sake, and the FAA is bringing everything out of that system down into our own system and then parsing it out to the customers that need it downstream. So there is an ALP update process. Obviously, the Vertipad is probably an ALP update process as well. So they would follow the, the on-airport Vertipads would follow that ALP update process and obviously work with the regions and ADOs on that. So completely outside the 7480 process. So anything on airport is really the 7460 ALP on file. I don't want to go down that road and confuse everybody, but it's just 7400, 7480. But so no, not right now. The only reason we're allowed to move the 7480 process, obviously driven by Section 314, but the fact that that system is owned by just the program management office in the FAA. So it's not maintained by us, not maintained by air traffic, not maintained by flight standards. It's kind of off on its shared services infrastructure, and we have issues, internally. Just to be very transparent with the group here, is it's tough to get requirements moving, and as this vertical community is moving so quickly, it just makes sense to allow some of the pipelines to come down into this system, especially those that are going to be in the system, come into the one-stop shop, and move on. So not at this time.
All right. And then, we'll work together with HAI, VFS, and the FAA to actually get the word drone port added to ADIP.
Let's
And
do
then
it.
we can start
I'm all
going down
ears,
that
for
road.
Sure, I'm all ears.
So, all right. And last call for any questions? Nothing? All right. So I appreciate your time, Drew. Thank you so much. And
Hey, y'all.
so you were scheduled for a 15-minute break. We'll go ahead and take a little longer break. You come back at 2:30 and we'll reconvene then. Mobility and eVTOL. So I'd like to introduce our next speaker, Colin Russell, Head of Safety from Lilium. Colin?
Thanks, Rex. When you can fire the slides up, that'd be lovely. Thanks. So I got asked late last week to deliver this presentation. So I thought it'd be really nice to come over and have a chat and to challenge us to think a little bit differently. Thanks. So they say you should never start a presentation with an apology. So I'm going to start with a warning instead. Okay, well, 3 warnings. First off is I have a potty mouth. I spent 19 years in the British Navy. The Brits are known for their swearing. The British Navy, the Royal Navy, is known particularly for its swearing. So if I apologize if I do drop now and then, but sometimes it's the way we normally talk anyway, isn't it? Really, as we were talking in the bar last night. Pub language. Again, back to the bar last night. You might detect a common theme already. But when we talk, I want to talk the way we talk normally, not the safety jargon that we seem to thrive upon as safety experts. And I'll come on to a little bit about why that in a minute. And the last bit is, I'd like it to be interactive. Please, if I ask a question, will somebody please come back to me and not leave me hanging out here? Okay, so that's my warnings, that I may be asking questions and I may expect a response, if that's okay. Cool. So to start with, I'm going to take you back to your childhood. Do you remember those little glass balls you might have played with as a child? The game of when you played marbles. They're just little glass balls like that. Remember them? Yeah? The interactive bit, yeah? You remember? Okay, good. Okay, the interactive bit, thank you. Those are little glass balls. So I'd like you to remember those little glass balls. And then I'm going to show you a pool. It's not just any ordinary sized pool you might have in your backyard. This is an Olympic sized swimming pool. You're probably thinking now that I might have lost those marbles and lost my marbles completely. But the reason I want you to picture that is I want to ask a question. How many of those little glass marbles do you think it takes to fill an Olympic-sized swimming pool? You thought John was mad when he was talking about mermaids on roller skates yesterday, but come on, this is going a whole league above. Okay, question. How many marbles does it take to fill an Olympic-sized swimming pool? Many, that's a good start. Okay, any more, any advances on many? Sorry, say that again? A billion. Ooh, okay, billion. American billion or a British billion? Just because we got to have different, units of measurement. Any idea? 1,000 million. If that's a billion in your book, that's fine. I don't know, a billion is a million in my book, or maybe 100 million if you're in a, who knows? It takes 1,000 million. Why is that an important number? Any idea? What's the numerical? If any mathematicians in the room, what's the numerical? Go on, Mike, come on. I knew the technical guy would bring it up. Go on. 10 to the minus 9, or 10 to the 9 indeed. So 1 in 1,000 million is 1 times 10 to the minus 9. Why is that an important number? That's the goal. That's the requirement, actually, for certification of eVTOL aircraft, certainly under the EASA regulations, and that's where it's coming or heading towards for, they obviously haven't released it all yet, but that's where it's going in that direction. So, yeah, so now imagine in your heads 1,000 million little glass marbles, but one of them's red. And every flying hour, the pilot reaches into the Olympic-sized swimming pool and pulls out a marble. If it's red, ... I'll let you fill it in. It rhymes with red. Okay? That is what 1 in 1,000 million, or 1 times 10 to the minus 9 actually means. 1 red marble in an Olympic-sized swimming pool of clear marbles. Okay, why? Why am I talking about this? 1 times 10 to the minus 9 is quite abstract in its head, isn't it? If I asked you to describe 1 times 10 to the minus 9, Mike could probably give me chapter and verse on it. But to most of us, 1 times 10 to the minus 9 is this mythical thing. Yeah? Is that a fair thing for me to say? You can challenge me and disagree with me, by the way, back to this interactive thing. Okay, so 1 times 10 to the minus 9, Olympic-sized swimming pools. Now I'll ask the question, that's quite an abstract, and I've just tried to describe it. What about safety culture? What's safety culture? What we do around here to get the job done when nobody's watching. You know, a series of artifacts and blah, 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 blah. Has anyone actually ever felt, seen, put their hands on, here, this is safety culture? We can't, can we? Safety culture is perhaps, to be challenging, is something over there. It's something we write on paper in our SMS manuals when we have to describe safety culture. It's something we write in our values and behaviors on the wall. How do we actually make it something else? How do we make it something we can actually do something with? That's really the first part of my presentation. So I'm going to talk a little bit about safety culture and some of the, maybe the challenges of even trying to use this phrase, safety culture. Because my gut feel, actually, I don't think it works. It's not working when we talk about safety culture because we keep on banging on about safety culture, don't we? We've been banging on about safety culture for years, even before the introduction of SMS and the management systems, etc. We've still been talking about it, but has it actually done anything for us? So that's quite a contentious challenge I'm going to make, isn't it? It's probably not what you were expecting. You're probably expecting me to either put a model from James Reason with the just, flexible questioning reporting cultures, or maybe Patrick Hudson's nice little elevator from a pathological safety culture to a generative safety culture. There's lots of academic thinking about culture, but it's not in organizations, is it? Really? Put your hand around it. Tell me you can put your hand around it in your own organization.
How about quality culture?
It's all okay, remember that potty mouth thing? It's all the same shit, okay? What I'm saying is to think of culture as something that we can do something with and something we can, all we do is write about it. It's very hard to do something, to make it come to life. That's my challenge. So I got challenged, sorry, there we go. I got challenged by a young lady who works at Lilium about 2 months ago. Because I used to be a safety consultant. I used to go and assess the safety culture of organizations. And she's one of our communications people, and she's great. She's helping me capture safety at Lilium and how we're building it, et cetera, from a pretty exciting new company. And she said, Colin, we think we've got one culture as a business. It's the Lilium culture. I said, but I've got safety culture. And I drew out the reasons 5 boxes, et cetera, as amended by Haddon Cave and all the good theory. And she said, yeah, I hear all that, but you put culture behind every word. But we've only got one culture. So, and culture's them, they over there. What about mindset? Oh, and it was like, I loved it. She's 24 years old. She's finished university. She's had a couple of years at university. She's really into comms and marketing, and she absolutely blew me away. And I went, yeah, you're absolutely right. It's not about culture, is that thing. Mindset feels more personal. And it's not just a jargon thing that I'm trying to drive. It's an approach. It's a mind. If you start thinking about mindset, our safety mindset rather than safety culture, it suddenly becomes more personal. Yeah? Is that a fair challenge to think about? How do we make it personal? How do we make it something that we can work on? So I'm going to tell a little story about why this is important. Okay? There's a language thing that we're struggling with. Okay? As safety professionals, we talk safety jargon. When you go and talk to people, just as was mentioned yesterday in a couple of the presentations, when you go and talk to people who are actually delivering the operation, they don't come back to you and understand what all the different risk words are and hazard and threat, etc. They look at you blankly, just like was mentioned yesterday. So I was the maintenance manager looking after a squadron of helicopters. And we had a problem one day. One of my supervisors came up to me and said, "Hey boss, you got a minute?" When one of your supes comes up and says, "Hey boss, you got a minute?" You know it's not going to be a good minute. So anyway, I walked out with him and he took me straight to one of the ground power units. And he pulled out the cable of the ground power unit and showed me the end of it. You can probably imagine where this is going now, but actually what had happened, all the pins were bent. Okay. He then took me to one of my aircraft, and on the side of the power receptacle was damaged, a bit was broken off, the pins were bent, it was all trashed. My first assumption, somebody else, not one of our team, had done it. Why? Why did I assume that? Because I joined the squadron 3 weeks earlier and been told we had a great safety culture, and the safety culture of our organization was amazing. And then I looked at this and I went, okay, so it must have been them, they over there. You can imagine there's always a bit of rivalry between organizations. Yeah, military organizations indeed. So we assumed it was the other buggers over there somewhere that did it. So I even went to their boss and challenged and said, "Hey, one of your guys broke one of my aircraft." Didn't say anything. To which he went, "No, we didn't." "Yes, you did." "No, we didn't." "Yes, we did." Okay. And then actually we worked out that it couldn't have been any of his guys because all his guys were away when we think this incident happened. So it must have been one of our guys. The worst bit was they'd actually damaged the aircraft, broken a bit off, and we found that bit in a bin. So they actually had consciously picked up that bit they'd broken off and put it in the bin and hadn't told anybody. Okay, this was really worrying me now. Okay, and eventually we did it. We had trained investigators on the unit. We did an investigation. We found out what happened, why it happened, all the good stuff, a series of recommendations. I sat down with the individuals and listened and learned about why they did what they did. 2 young guys, been out of training, come through a whole training pipeline, 4-year training pipeline. This was their first operational squadron, and this is what happened. A couple of days later, they actually got sent out of theater back home. But a couple of days later, I sat in the crew room, one of those old converted shipping containers, and I sat down and had a cup of tea. I'm British, okay? It had to be tea, not coffee. And I sat down with the team, the young guys, all the guys out in the line, and I said, "Guys, what do you understand by just culture?" What do you think their reaction was? Okay, interactive bit again. What was their reaction when I said, what do you understand by just culture? I get a shrug of shoulders, Brian. What's a just culture? What's one of them? There were a few bits of language in between what is something in a just culture. They looked at me blankly. I was like, "Guys, come on, just culture. You must have done this as part of your training." I know that because I went to visit our safety center and they always bang on about just culture. Still looked at me blankly. So I said, "Oh, excuse my language, okay? It really is going to drop now, if that's okay." I said, "What do you do if you fuck up?" And then they looked at me and went, "Well, we tell somebody." I said, "Okay, now we're getting somewhere. Why?" "Well, we'll tell you because you want to know." "Okay, good. Keep going, keep going. Why do I want to know?" "Well, you want to know so you can fix it, boss. So you can stop it from happening again." Like, yeah, that's a just culture, isn't it? If you screw up, own up, because we're not interested in who, we're interested in why. And suddenly, that became the mantra of the squadron. Sorry, can I have the... If you screw up, own up. I'm not interested in who, I'm interested in why. That became our just culture strapline, if you wanted to put it under a regulatory banner. Didn't mention the word just culture once. Because one of the real challenges we have is we stick as safety professionals, we take our regulations, and we write words that people outside of the safety world don't actually understand. And actually, most of the people in the operations, even in the management level, don't understand it. But we still get frustrated that no one's listening to us. Well, it's because we're speaking safety gobbledygook, and we're writing it in manuals that are structured in such a way that no one ever accesses the information. Yet we keep on banging on about why we don't have a safety culture, or we need to improve the safety culture. Is that a fair challenge for me to make, do you think? Yeah? Okay. So here's another one. Okay, I know this is an EASA regulation. It's not an FAA regulation. Apologies. I'm a little bit more comfortable with the EASA system, but this is the requirement for a safety policy. You guys have all got a safety policy, right? Yeah. Everyone who's got a part, I think it's part 5, isn't it? Part 5 SMS, approved SMS. You must have a safety policy. It's part of the 4 pillars of ICAO. Yeah. You can hear the jargon coming back again. The 4 pillars of a safety management system under ICAO. What's number 1? Safety policy. So everyone has a safety policy. And what does it say? It probably says all these words. Probably exactly the same words in your safety policy. How many safety policies do you think are taken from the regulation, regurgitated and stuck back up? Yeah? Most. Okay. So if I'm reading that, that probably all makes total sense to you, doesn't it? Because you're all safety professionals. That's why you're here at a safety conference. We never get CEOs or operating officers or heads of flight operations, etc., at these safety conferences. We always get the safety people. But anyway, your safety policy probably looks like that. And it probably is available to all personnel. I went to one airline where they'd written their safety policy that was so regulatory pure, you could imagine the auditor's reaction or the inspector's reaction when he had to audit it. And it was stuck on the wall. And the instruction was given to the facilities guy. Here's a framed safety policy. Please go and put a copy of this in every single meeting room in the company, because then it's been promoted. Unfortunately, the infrastructure guy that went and did all that, he stuck it up in the wall, but he stuck it up in the top corner of the meeting room. Now, in this case, the ceiling's quite high, but even just imagine a normal sized meeting room. Oh, this thing was only A3 size, so the text, and there was so much text like this in there, you could hardly read it from 2 paces away, let alone when it was up in the top corner of the wall, out of the way. So no one they could put the normal pictures up everywhere else. Regulatory compliant? Yes. Was it available? Yes. Yes, it was available to all. Completely missing the point that actually the safety policy is the anchor around which you drive safety in your business. But we write it for who? When we use all these words, who are we writing it for? The compliance officer, any other words? The inspector. We're writing how we're going to manage safety in our business, not for the people in our business, not to help the people in our business, but to help the regulator. Really? Is that what our job is as safety professionals? The leaders of safety in our organizations to drive that kind of approach? But that's what we do. So some of these challenges are part of why I think culture is the wrong kind of mindset, the wrong, this compliance, this following the rules, this workload. Why don't we speak in pub language? Why don't we talk to our people actually in ways that we would talk to them in a bar? Imagine if one of your friends said in the bar one day, said, "Hey, what do you do for a job?" "Oh, I'm the head of safety. My job is to manage risks to as low as reasonably practicable. Yeah. I have to understand what the threats and hazards are in the complex operation we deliver. Yeah. I have to write a safety policy that reflects organizational commitments regarding safety in its proactive and systemic approach." What do you think your friends would do now? You'd probably be sitting at a table by yourself at that point, and they would have gone off and talked to somebody else. So my challenge to you all is, how do we bring safety to life? How do we generate a mindset where we can talk to each other, listen to each other in words that we actually use and normally understand? Because another challenge that I hear on this sort of stuff is, well, we have a culture, an organization. And actually, one of the first things we do is we draw the organization with boxes, don't we? And lines, and dotted lines, and dashed lines. And I've even seen double dotted and double dashed lines for how the organization works. And that's another thing we have to draw. Why do we have to draw that in our safety organization? Because the regulator wants to see it, doesn't he? They want boxes and lines. And the first time we have to do a change, the first thing we do is we alter the boxes and lines and the dotted and the dashed and the double dotted and the double dashed. We don't work in organizations. We don't work in boxes and lines, do we? That's all sort of written down stuff. We work from here. Who do you trust? Interactive. Who do you trust? Any ideas? There's a hint in the picture. Who do you trust? Come on, guys, you at the back. Who do you trust? Hmm? All of them. In your organization, who do you trust? All of you, really? Apart from him. Okay, so now we're getting somewhere. You see, now we're getting somewhere. What about you guys? Who do you? Friends. How do you write friends in an organizational manual? Anyone else? We work in tribes, is the answer. That's why I chose this picture. We work in tribes. Okay, who's in your tribe? Because if someone feels like they're in your tribe, you'll trust them. Have you ever heard the phrase OSB or OWB? Other shift bastards or other watch bastards. It's a maintenance phrase. Okay, when you have two shifts working, yeah, one shift will always call the other shift a bunch of bastards, whatever language they want to use, because they're the people that always don't get the job done. And they leave it up to the other shift, or they want to get away early, or they didn't do the right thing, or they failed to fill out the paperwork. And it's us and them. You'll trust the people on your own shift, and you won't trust the people on the other shift. I've got some laughs and knowing nods. I'm obviously making this is going all right. Okay. But we trust our tribe. So who's in your tribe? Organizations. We talk about silos, don't we? Silos or isolations or islands. We always have this problem because we don't have that trust. So how do you start to share this trust more widely? Well, you write a policy about just culture. That'll solve it, won't it? You do boxes and lines and you rearrange the boxes and lines because that'll solve it. No. How do you get people to share trust? Because actually, if you want to talk about safety mindset, safety, whatever label you want to put on it, that's what safety is about. It's about here, isn't it? It's about caring for and giving a shit about each other. And it's not, I'm not talking occupational safety, I'm talking every kind of safety. It comes from care, it comes from here. Safety is not a here thing, safety is a here thing. Safety is done by people, not by process. You can imagine I work with a lot of quality people and I say safety is done by people, not by process. And they kind of almost stop breathing for a minute. It takes both. I'm not saying it's one or the other. It takes both. So let's talk about this mindset or culture or whatever you want to call it. Yeah. How do you, with your SMS, how do you switch your SMS on? How do you bring your SMS to life to actually do something for you? Interactive, interactive. When I put a question out, please. How do you get your SMS to come to life? Education. Okay. So you transfer knowledge of what an SMS is. Here's a challenge for you, Will, if that's okay. Ask somebody who isn't a safety professional to review the education that's been delivered on SMS. How many times does it start with, this is ICAO, this is the FAA structure, this is how the regulations flow down, this is section 5. So that's probably taken the first 30 minutes of SMS training for operators or maintenance staff or anyone else. Is that a fair challenge? So how many people in the audience are still awake at that point? Okay, and then we say, and here are the 4 pillars of ICAO. And we start off with pillar number 1, and then pillar number 2, and pillar number 3, and pillar number 4. Is that a fair challenge? I'm not trying to be, I'm just trying to be a bit of a mirror. A bit of a difficult mirror, but a bit of a mirror. Because that's how we write the training for safety professionals. So most people come out of the safety training with their heads down, going, God, just another year till we have to do that all again. Because the recurrent training is just the delivery of the same training again. Yeah? So safe, but education, transfer of knowledge, absolutely. There is a part. How else? How else do you bring your SMS to life? Okay, good. So we have feedback. Yeah? Feedback is I refer to it as the breakfast of champions. Yeah? If you don't get feedback, you can never learn. If you never learn, you never improve. If you never improve, you never get safer. So you're absolutely spot on. That's one part of it. So you've got to be able to, if someone puts a report in, you've got to be able to feed back and explain to them what you've done about it, how you've made an improvement, or even, sorry, we haven't been able to do anything, but thanks for your report because it's really valuable. Anything else? Active risk management, that switches an estimate. So how do you do active risk management? I'm being really difficult, aren't I? But this is one of the challenges, is actually to have a conversation rather than just sit here and listen to me talking for an hour. You guys would be deadly dull by then. Sorry, I would be deadly dull by then. You'd be very bored. Sorry, you're saying an active risk management. How do you do that?
So you look at risk to the business, assessing them, and looking at what the consequences of that.
Yeah, so the whole process of risk management. Yeah. Okay, here's a challenge, because I'm going to be that bit difficult mirror again. Here's one of the challenges I've seen an awful lot of. We generate a risk register. We do exactly that. We identify our hazards, we assess the risk, we use a matrix. It's normally got 3 or 4 colors in it. So we work out what the color is, and then we put that color at the end of the box and the end of the line of the risk register, which has probably got somewhere between 100 and 200 entries in your risk register. I've seen up to 500 entries for one small organization in their risk register. And then what do we do with it once we've done the risk assessment bit? We're done. We've done the assessment. Look, we're compliant. Here, Mr. Regulator, we're compliant. We've done it. Here's our risk register. What's the bit we failed to do? I'm being challenging, I know. I'm being difficult, okay? What's the bit we failed to do once we've done the risk assessment bit? Test it, manage it. How's about actually do the shit we said we were going to do in the risk assessment? Yeah? Sorry, I missed that bit. Yeah. And then even if we do that bit, what's the next bit we failed to do? We then failed to go and check that what we said we were going to do, that we actually did, if we're lucky, has actually had the effect we wanted it to have and has actually reduced the risk. Because most of the time we say we're going to do something thinking it's going to manage the risk. Sometimes we do it, but actually it didn't have the effect we wanted. It didn't do what it said on the tin. So we still have the risk there, but we think we've managed it down to here, but it's still up here. Fair challenge? But your point, you're absolutely right. Active risk management is part of switching an SMS on. What else? There's a key word I'm looking for that I haven't heard yet. I'm trying to draw it out from you. Come on. Leadership. Thank you. Leadership. What's a leader's job? Because leaders get the culture they deserve, apparently. If you read some more academic stuff and more of the management books, etc., it says leaders get the culture they deserve. Culture eats strategy for breakfast. This back to this culture thing somewhere, but the mindset. How do you switch on a mindset in your people? Through leadership. Set the example. You live it. You live what's written in the black and white. So you bring the manual to life. You bring your values, your statements, everything you've written to life. What's the basis level of leadership? If you look at any good leader that you've ever worked with, any great leader, what made them great? What made them really great? The great leader, you think back and you think, I'd follow that person anywhere. They cared about you, yeah? Leadership is about giving a shit about your team. If you give a shit about your team, they will care about what's important to you. Yeah. If you say, by the way, guys, safety is really important to me. I live by example. But first off, to get them switched on, to get your safety management switched on, your SMS switched on, you have to show you care about them. Because if you don't care about them, they won't care about what's important to you. And by the way, shareholder value isn't something that employees never care about. So don't make that what you care about as a leader. You've got to care about the people, because it's back to the heart. It's back to the tribes. They'll trust you and care for you if you care for them. How many times do we write that word in our safety management manuals? Is that a fair challenge? So the reason I do it is this. What does this picture look like to you? Give me one word that sums up that picture. Team. Okay, that's a good one. Anything else? Bond. Okay, good. Anything this side of the room? Come, I've been asking these people over here. You guys need a bit of trouble. Come on. What do you get from here? One word. You can get a bit emotional if you like. Love. That's the one. Do you know what? I was looking for images because I hate having PowerPoints with lots of bullets and stuff on it. So that's exactly what I went for. I was looking for, and I looked at this and I just thought love. Love in a team, not in sort of the social context or whatever. This is clearly some team of young men who are in some kind of sporting context, but they care about each other, don't they? They clearly care about each other. Do you think they'd look after each other? Yeah. Do you think if one of them had a problem, they'd share it? If one of them injured themselves, do you think they'd look after each other again? Do you think they'd help each other stay safe? Yeah,
because they care about each other. So the fundamental premise of a safe mindset, being safe in your organization, is the risk assessment, everything else is good. But if you don't care for each other, then no one's going to follow the rules. No one's going to follow all the processes and all the admin and all the paperwork and all the bureaucracy that we've put in there. So to come back to the title of the presentation, safety culture, yeah. Words, it's just words. It's a lot of academic words, but I've rarely seen it actually walk into an organization and I can taste the culture around here. But you can certainly tell if people care about each other, can't you? Just in the way they interact, the way they get on with each other, the way they talk to each other and look after each other. You go and have lunch in an office, there's a canteen or something like that, just watch how they interact. And you'll know whether it's a safe organization or not. Is this going okay so far? Is this kind of what you thought it was going to be? No? Okay. Okay. What's important to my boss is really important to me. To come back to that leadership bit and for leading by example. That's the inspiration that drives a lot of great leaders. Not business targets, not milestones, certainly not shareholder value, that's for sure, or stock price. But we have to have KPIs because the regulation requires us under safety management to set under our safety assurance pillar from ICAO, we're required to measure safety, aren't we? So how do we measure it? What indicators have you got? Give me examples of indicators that you set. Any examples of indicators that you guys have set, safety indicators? Number of safety reports submitted. So is the number going up a good thing or a bad thing? Could be either way. So what else do you need to know? How much time taken to analyze the report? Why do you do that? Why do you measure that? Okay, good. And so nothing's left behind. Okay, good. So you're doing a bit of prioritizing and filtering. Okay. So if all you do is measure how long it takes to get the report done, we've got to be careful of the second order behaviors and consequences. Every indicator drives the behavior, but not the behavior you want. The behavior that's the easiest thing to do. Yeah? So if all you're doing is measuring how long it takes to process a safety report, particularly if you put that metric on the operation, not just the safety team, you'll see the number getting better and better and better. Because everybody wants to keep their boss happy, don't they? But actually what's happening? The quality is going. So unless you have a countermanding metric where you look at how many reports are rejected or how many actions are rejected, yeah, then you can see if both numbers go down, that's good. If one number goes up because they're all being rejected because they're all low quality, but they're being done on time. So it's also be wary of the second order effect. Same with yours. You said the number of reports. Well, if the number of reports is going up, it's a good thing. It might be if they're all proactive hazard reports, but if they're all occurrences and you're seeing more and more occurrences being reported, may not be such a good thing. That may be an indication you've got bigger problems. So again, we set these metrics, but we don't really understand what's the question. The question we want to ask, and actually, can we even measure this? But interesting, you both gave indications of leading indicators, which is good. That's a good start. Most people say the number of accidents we've had. That's not a very good safety metric, is it? That's a non-safety metric. So okay, anything else? What are the metrics? What's the reoccurrence rate? That's quite a good one. Yeah, so you're seeing whether your actions have been effective. I like that one. Anyone else? Come on, this side is very quiet. Come on. Any indicators you guys set? No? Okay. Do you need indicators? Why do you need them? Because what gets measured gets managed is a phrase I hear an awful lot. Anyone heard that phrase before? It's one of the great MBA phrases. Every person that's done an MBA has probably been told that 1,000 times. Yeah? Problem is, even when it's pointless to measure and manage it, it even harms the purpose of the organization to do so. We still measure it because we think if we can't measure it, we can't manage it. Sometimes you can't measure this stuff, and that's okay. But sorry, third pillar of ICAO's 4 pillars of safety management systems requires us to have KPIs, doesn't it? So we have to measure it. So that's me talking a lot about
safety management and safety culture, safety mindset, safety, all that stuff. What about this lot? It's coming, isn't it? And fast. How many of you are comfortable with what's happening about the world of advanced air mobility? How many of you are comfortable that this new sector of aviation is arriving rapidly? You're comfortable? Okay, good. Anyone else? No? You're comfortable with one corner of the picture. Okay. So I'm not sure whether that's Maker or Midnight. I'm comfortable in some ways, but I'm really uncomfortable in others. Why? Fear of the unknown. That's a really good point. I like that. Anything else? No standards. We're developing the standards. They're all being written. We're working, we're all working with the regulators to write the standards and make sure we stay safe. And the standards are good, but they're the bedrock. They're the minimum, aren't they? You can't go below the standards, but you can always go above them. Is that a fair challenge? More than half of what I show are not aviation companies. That's not true. The reason I say that's not true is in order for these things to fly, they must be aviation companies. They might not have a 20, 40, 60-year history of aviation, but that doesn't mean they're not aviation companies. And that's one of the challenges, is to make sure that every organization that's doing this is ready to be an aviation company before they start flying. So yeah, it's now under 50%, but somewhere between 40 and 50% of employees at Lilium don't have a deep aviation background, but they are incredible people. They come from Formula One. They come from energy management. They come from advanced composite manufacturing. They come from all over the world. We've got 54 nationalities at Lilium, and we've got an average age of around 30. And it's incredible. I love it. Sorry, that's not me just picking up Lilium. That's me just inspired by the people I work with. But it's really interesting because we're seeing a diversity of thought.
Can I speak to the point about what he made about
Yeah. Okay. Yeah.
So that is actually more to it than what he said, because I know you don't like the word safety culture, but if there is an aerospace company that has been around, right, I'm just playing devil's advocate.
Yeah, that's good. I love it. This is what we should be doing more of.
So if there is a company, okay, thanks. So if there is a company that has been around for 10 years in aerospace and they are developing an aircraft, right? I'm not talking about the first aircraft, but they have developed one before and flown and all that, right? So assuming the same people stay there, the knowledge, the experience that group of people have cannot be replaced just by enthusiasm and hard work. That when I say an aerospace company, that's what I would be.
I don't disagree with you at all. I think you're absolutely right. But we have to build and know that we have to build that. And then that's when I say who's comfortable, who's uncomfortable. Yeah, I'm comfortable that we're going to be okay. What I'm uncomfortable about is assuming we're okay. That's the dangerous bit. But this is great. This is a whole new sector coming in. It's awesome. One of the challenges, however, is that our safety record in aviation has been built on the shoulders of giants because we've learnt and learnt and learnt from when it's gone wrong. Yeah, every regulation is written in blood. Okay, everyone who works in a regulator knows that if they want to introduce a new regulation, the easiest way to do it is to link it to a recommendation from an NTSB or an AAIB report. Yeah, you can go, there's the accident, there's the recommendation, here's the regulation. Got any problems? So the point I'm making on this one is actually it's coming fast. Yeah, it's challenging, but we're building on a safety baseline that's come from a huge amount of aviation. And we're all working together to deliver it. But it's not easy, is it? No, I think I'm looking at my colleagues and worthy rivals in the room. Yeah, it's not easy. But here's a challenge for you. Has anyone come across game theory before? I'm going to ask the question, and I'm going to ask the question challengingly to my worthy rivals and fellow colleagues from other OEMs. Who's going to win? If there's an accident, no one. That's a great point, okay? This is the challenge that we face in AAM, okay? And I heard someone the other day saying, well, we have to accept there are going to be accidents. Accept there are going to be accidents. We've got to keep working to strive and work hard to make sure there aren't. But if we don't even know the game we're in, because one of my friends, again, in the pub, speaking in pub language, asked me who was going to win at AAM. I said, okay, define win. He said, well, who's going to be the first? I said, is that winning? First what? First certificated aircraft, first aircraft into service, first passengers flown, first £1 million of profit made, first what? Don't know. So ask me the question again, who's going to win? Don't know. Does it matter? What matters is that we keep the game going. We keep the new sector going. Because if one of us loses, we're all going to lose because the game will stop. And that is what I mean. And that's the infinite game theory. So there is no winning in advanced air mobility. The game we're playing is an infinite game. The game we're playing is to sustain the game. And we all have a part to play in sustaining the game. Why am I talking about game theory now? Collaboration versus competition, exactly. We cannot afford to compete. Now, you've heard that Heli Offshore is a great organization because there is collaboration going on in the helicopter world. This is collaboration, isn't it? What we're doing here. What's the challenge about what we're doing here? If I want to see the record of the vast conference next week, what am I going to see? I'm being really challenging, I know, but I get to. I'm going to see lots of presentations and lots of information. How many actions are going to come out from what we're talking about for 3 days? How many man hours have we got sitting here for 3 days? How many actions are going to result? Is that a fair reflection? If I'm being really challenging? Because it's the collaboration. When we say we collaborate, we tend to go to conferences. We drink wine and beer and margaritas and sambucas and God knows what else we drank last night. But tend to walk away from the conference and go, right. And then suddenly you open up your computer, there's 101 emails waiting because you haven't been able to look at your emails during the conference. And so you get back to the day job and within a week you've forgotten the conference. So we've got to think about not just collaboration, but collaborative action. Yeah, taking time to think together and collaborate to take action. That's the challenge for me, and I don't think we're very good at doing it. So Simon Sinek is the guy who popularized game theory from the academic who came up with it. But he said, we have to stop thinking about who wins or who is the best, and we start thinking about how to build, it says organizations, but our sector that is strong enough to stay in the game for many generations to come. We do that by taking collaborative action. What's this picture trying to show? What's wrong with this picture? It's pushing a negative agenda. Okay, that's a good phrase. Anything else? Hasn't been a great amount of coordination, you're right. Where's the regulator in all of this? Trying to keep up? Yeah, you can't write a regulation for something that doesn't exist formally yet. This is all experiments, isn't it? Long-term experiments, but they're in that stage. Anything else? I come back to if one of us goes down, we all go down together. The question for me is, how many times has some kind of automation or advanced system in a car stopped an accident? I asked Nancy from NASA at lunchtime. On my Golf, my 2013 Golf, I have adaptive cruise control. And basically, it's a system that stares at the car in front of me. It's amazing. How many times has that stopped me having an accident? 5. 5 accidents that haven't happened because I relied on a little bit of technology. But we're not very good at sharing how many times we've saved ourselves, are we? So that's part of the job we have in AAM, is to tell the good story as well. Okay, not just, hey, we haven't had accidents, but to tell the good story. So I want to share in the spirit of collaborative action, where we need to recognize and learn very fast and share some of the stories. Yeah, most of the time the presentations and people at conferences don't talk about problems. They talk about what they've achieved.
So I've got one. Who loves lasers? Everybody but pilots. Yeah? Last year, how many laser strikes in the US? Any idea? Just under 10,000, 900, I think 9,984 or something like that. Thanks, Tom. They were the only ones that were reported. So for every one that's reported, how many pilots have given up reporting laser strikes? Quite a few, because there's really not much you can do about it unless you happen to have a police helicopter right beside you at the time. You can then follow the laser beam and go and actually find out where it is. Because if you don't, you've got no chance of finding out exactly where it came from or being able to catch the perpetrators. So why am I talking about laser strikes? Let's come back and do a dynamic risk assessment, shall we? To talk about your active risk management piece. Let's talk about the probability and severity of a laser strike on an AAM aircraft, a manned one. So Dave, thanks, but you can sit back for a second. You've got other problems to worry about. Okay, but this one is a manned AAM one. What's the probability of a laser strike on an AAM aircraft? Higher, medium, or lower than general aviation? Higher, why? Closer to the ground, we're flying lower. Yep, we're flying along predetermined paths between nodes, yeah, vertiports. I'm not going down the whole vertiport conversation again today, by the way, it's okay. But we're flying along known nodes. And what else? Urban areas. We're flying over populated areas, exactly. So the probability of a laser strike is higher. What about the severity? Any HEMS pilots or HEMS guys involved? No? Thanks, Rex. So HEMS, fly single pilot most of the time? Yeah. What happens if you're flying single pilot? You can't say you have control. That's the problem. Well, you can maybe if you're flying one of Dave's aircraft because you don't, but you don't have the ability to hand off control to your co-pilot whilst you blink, clear your eyes, try and shake, and hopefully you've got your vision back after about 10 minutes, if you're lucky. So, good case for autonomy. Yeah, it's going to take a while, isn't it, Dave? Yeah, we need to think about something before autonomy. It does. You're absolutely right. So what do we need to do about that risk? Because we now established that laser strikes, and this is not a Lilium problem. This is an AAM sector problem. Okay. What do we need to do to reduce the risk? 2 pilots, autopilot. Autopilot can't land it most of the time, so it gives you time, perhaps. There's another challenge in AAM that I will, electric, certainly AAM. What can we do? What do HEMS pilots wear, Rex? They wear goggles or glasses. You can buy a laser filter goggle or glasses. So imagine now every pilot who flies an AAM has to wear laser goggles. That's okay, isn't it? That's a bit of PPE, protective equipment. We can issue it to people, remind them to require them to wear it in our procedures manual. Is that robust as a mitigation or a control measure? How comfortable are they to wear? What happens if they forget them? Yeah, do they remember? We're all human, we all forget. They might have forgotten to put them on. What happens if we design a mitigation into the aircraft by fitting a laser filter into our transparencies? Would that work? See, you guys are good. I'm looking, there's some good chat going on there. What's the problem with that? Cost, okay, part of it. Anything else? You have to put it into the design of the aircraft. It's too late once you start operating to put something back in the design, isn't it? So we've identified this as a risk. I've put a requirement into the aircraft to have a laser film fitted to our transparencies. But hopefully not just to the cockpit, because what about all the passengers? Hi, welcome to your first ever AAM eVTOL flight. Here's a pair of laser goggles. It's not going to go down very well, is it? So we need to think about our passengers as well. These are all the things that we're starting to think about. What have I missed? That's one I've shared. What have I missed? I don't know. That's the challenge. I'm not amazing. None of us are. We're all human. We can all miss things. So as part of the collaborative action element that I'm talking about, wouldn't it be great if, so I've just shared that with all my worthy rivals. All the safety guys from all the other AAM companies, manufacturers that are here, are going to go back and they're going to go, Guys, what are we doing about laser strike risk? How are we going to protect our people from that? You see, I bet you made a note already, haven't you? You see? And that's great. That's collaborative action in action, isn't it? So tell me, what are your risks that you're managing that I might have missed? I'm going to sharing the love two ways, you know, it's not just a one-way thing. Okay, so and a lot of those we cover, but isn't it pilot distraction? Great, we're back to our single pilot. How do we help the pilot not get distracted? Do you know what? I made a mental note of that one. I'm going to go back and check myself. That's collaborative action two-way, isn't it? That's how we're going to keep the whole sector safe. Thanks for the two-way conversation. But you see what I mean about collaborative action versus collaboration, Tom?
I was hired on HI to help get the vest off the ground. We have, after today, we've already had 4 technical working groups. We would be glad to have people come and collaboratively help and try and answer these questions. We have technology, we have safety promotion with 5 of them, and also HAI has their own working groups. First thing and also there are many regional safety teams. If you're in the US, that's USHST. We have Chile, we have the Europeans, EASA, and things like that. We have people coming to us asking how they can help. I encourage everybody to get on the VAST website, vast.aero, send a message, and that will come to me. And I will get back to you and talk about where do you think you can fit in to help with the safety aspects of everything vertical flight.
Brilliant, thanks, Tom. So I'm being challenging. That's part of the challenge of being up here and engaging the conversation. You're absolutely right. There is collaboration happening, okay? But we need more, and we need to make sure it leads to action. Not just, I mean, I've been to a number of working groups and things before, and sometimes they have actions, and sometimes they deliver stuff, and sometimes they don't. So the challenge is to make it really effective, and that's always the challenge of a working group. I mean, but you look at what Nick was talking about yesterday when he talked about the safety enhancements, the HSEs. There's some really good stuff happening. I'm not decrying saying there's nothing happening. What I'm trying to do is challenge actually to keep going into, in particularly in our sector. And actually, it shouldn't need to take a whole working group and a whole flying bag. It's a conversation. I think we've already agreed that, you know, just talking with each other and spending time with each other is a great thing. So it's about collaborative action. And we always use the phrase collaboration. I encourage the phrase collaborative action. So we need to understand the game we're in. It's an infinite game. So our job is to keep the game going, not to try and win, if that makes sense. We need to be transparent. I think we've just shown transparency 2 ways, which is great. Thanks, Pedro. And we need to take the action. So back to that active risk management you were talking about at the very beginning during the conversation. It's all very well identifying the hazard and the mitigations, but if you don't take the actions, you won't actually reduce the risk. I'm going to go back and start the one again. Can we get the audio on this one? Shall I try it again?
Safety at Lilium is a really interesting concept because we're doing everything from design all the way through to the operation of the aircraft. And we also have to look after our people, our business, our suppliers and customers. So collaborating across the eVTOL and advanced air mobility space, it's essential because we can't afford to compete on safety. We have to work together because we're all going to learn lessons at different times. We're already starting to talk with the other manufacturers and the potential operators out there. Safety is not just about stopping you getting it wrong. It's about finding the way to get things right. We're understanding and learning every day. If we didn't learn, we wouldn't be improving and constantly striving forward.
This is our test center down in Spain where we're currently flying one of our technology demonstrators. It's a great place and the olive oil is incredible. But I want to leave some questions with you because again, part of the idea of these conferences is to cause us to think, okay? To cause us to think and to challenge ourselves. So a few questions here. So does safety culture really exist as a thing? Up to you to make that call or use whatever language, but hopefully I've challenged you that if you
If it is a thing in your mind and you believe that, then how do you bring it to life? How do you actually make it real? How do we help our teams get it right more often? Safety is a lot about catching us doing it wrong. How do we get it right more often? Because that's our job as leaders. Yeah, when we care about our team, we help them get it right more often. A little bit about the infinite game there. Are we learning and sharing to help our whole sector? Are we taking that collaborative action? And finally, do we know what actually drives our amazing people every day? As leaders, we should do, because that's what we need to work on to help keep us safe. Any questions? Anything? Bloody hell. Was I that good that you don't have any questions on what I've just said? Because I've got 5 minutes still, Rex, if that's all right. What about online? Are there any questions online? Sorry, I've kind of been so busy gobbing off to everyone in here that I've forgotten about you guys. No questions, no challenges. Okay, yeah, see? I'm going to bring the mic over here first, if that's all right.
What's your plans for a power loss situation with your aircraft?
What's our plans for a power loss? What kind of power loss? How long a power loss? Which? Okay, what's our plan for a power loss? Redundancy, it's one of them. Alternates. We've got to look at all the different, how you set up your operation. How far away can you be from safety? You know, you got to, it links from the design all the way through to the operation. It leads me on to an interesting point, is that safety doesn't stop at the design. 1 times 10 to the -9 is the start. You've got to certify that. But everything else, the bit that I didn't mention, just to come back to that bit, is once they finish the design, the 1 times 10 to the -9, we then get buckets of red marbles and throw them in. That's called the real world, isn't it? The design is on paper and proven in system testing, but that's only the start. We live with red marbles day in, day out. And our challenge is to keep on pulling the red marbles out and pull them out faster than they're going in. Yeah? Is that a fair way to finish off the crazy marble analogy at the very beginning? So that's a little bit. We can talk more privately when I'm not being streamed. We'll talk a little bit more about that.
What is safety culture?
What is safety culture? What do you think I think safety culture is? Okay, what do I think safety culture is? I think safety culture is an attempt, a well-meaning attempt to try and capture something that's uncapturable. Okay, so to me, I don't think safety culture as such actually exists as a thing. I think safety, if you wanted, I think safety is something that we all know, think about, we all know about, but it's very hard to define it. You look at how many different definitions there are. But to me, it's about helping our teams get it right, caring for them so they get it right more often, so that it goes wrong less often. Does that sound like a reason? But good question. If we asked every single person here to quietly write down what they think a safety culture is, you'd have 30 different answers. Next time I like that.
Thank you. I think from a regulator point of view, to drive safety culture, they should hire people like you and make it through the organization. Thanks.
No worries. Hey, Pedro.
So we have a full panel to discuss stuff tomorrow. Don't want to take too much content out of that, but I did take a few notes over these last couple days that connect to some of the things you were talking about. And I kind of agree with you that safety culture is too abstract to be useful in some cases, but how people understand and deal with some of these points is an element of how your organization responds to real world situations. So the first one is divergence between individual risk judgment and organizational or societal risk judgment. I've heard many times these last 2 days, you can't fix stupid. People do stupid things. People don't actually do stupid things in their own mind, right? They do things that appear stupid in hindsight or appear stupid to us by our value judgment system, but at the time they seem like reasonable risks to take. Even the example of whoever damaged your airplane and walked away from it, didn't tell anybody, I guarantee you they thought, nobody's going to try to fly this thing. It's obviously damaged. I'm not hurting anyone. I just don't want to get caught. And in their mind, that was an acceptable risk. And then how do you manage that across an organization where individual judgments that are out of line with your objective are an actual problem? So I think that's something, if you start talking to people about that, you've opened an opportunity to align on that issue and improve your safety culture, whatever that is. The second point I heard a lot is limited resources, right? Or in the way that I like to talk about it, the safety cost of complexity. Because everybody can talk about money cost or time cost of doing things, but there's a real safety cost of making things complicated. So we heard conversation about SMS and, I implemented SMS. The only thing I got was this stupid checklist. Well, if you add a bunch of labor to get your basic job done, then all that labor is coming out of somewhere, right? There's not infinite resources to throw at a problem. If you add a bunch of bullshit, to use proper language, all the time spent on bullshit is coming out of time that could be spent on doing something actually useful. So belaboring your procedures is actually diminishing your safety in a way. And the third one is a really big issue, is rule following versus thinking. Are you ritualizing safety? Follow this checklist and you will be safe. You are actively reducing your safety because you're taking judgment out of the equation.
I couldn't agree more with the last point in particular. So there's a panel session tomorrow about SMS for small operators that's going to address most of those points, because a small operator can't afford to do anything you just said. So yeah, we'll talk about that tomorrow. Brilliant.
I saw recently an OEM saying that they were going to try to have wireless charging for their aircrafts. And I asked them why they wanted to do that, because energy-wise, it's not very efficient. And they said, well, basically that allows us to have nobody on the field, nobody on the apron. And safety-wise, that sounded really, really unwise. So, but I was surprised that this was basically a decision that was taken really at the design level without knowledge of the operation. So for me, that was really worrying to see that. Are you taking similar ways?
So I think how the aircraft is actually operated at the end, based on the initial concept all the way through, is something that every manufacturer of every aircraft goes through an iterative process. They come up with an ideal concept. It's a bit like a concept car. You look at the Frankfurt Motor Show or the Detroit Motor Show, and there's some concept cars. They never actually look at that when they come off the production line. And I think there's a bit of that going on, the concepts and then iterations. So maybe that's the initial design intent would be amazing, but actually in reality, you're going to have people around on the apron or on the teal-off, et cetera, or supporting the operation anyway. But the interesting thing for me is it's the risk mitigation. The decision to not have people there, or the decision to actually put more people there based on another decision, means that you're actually transferring the risk from the design organization through to the operation. If they don't know about it, they don't know about the risk they've got to mitigate until when? Till it's too late, exactly. So that conversation between all the way down, Brian from Bristow's here in the room. Brian and I, we're talking already because Brian and Bristow have signed up with a number of OEMs, and we're talking about the operation back into the design, back down to the operation, because we need to understand exactly these challenges early, don't we? So that's the kind of conversations that have to happen. I think I've run over time, Rex. I'm sorry.
Only a couple of minutes. You're good. So. No, I appreciate that. Round of applause for a invigorating discussion. Now, having been in your shoes as a safety manager, people ask, "What's a safety culture?" I says, "It's witchcraft. It's ethereal magic. It's hard to put your hands around." But a lot of times, you'll go in and ask somebody in a program, say, "Hey, tell me a little bit about your safety system or your safety culture, your SMS," and invariably they'll go over to the wall and pull a manual off the bookshelf. And when you have something that's been closed up for like 3 years and you open it up and it cracks and it pops and it peels, that's their safety culture. It's on a manual. I'd say the best thing I can say is if you're going to have a safety call, you got to give your personnel, your people that work for you, authority, not just responsibility. Anyone should be able to say stop at any time. That was one of those big lessons we learned in reading the book, The Toyota Way, if you ever saw that. Anybody on the line can pull the lever and say, "Stop, I see a problem." And no repercussions whatsoever. That's unheard of in a lot of cultures today. So great discussion. Greatly appreciate that. Our next speaker, I believe he's here, Steve Haney. Yep. How will hydrogen power, or how will hydrogen powered VTOL work, and what will their impact be on the industry? So this is an area we've talked about electric. We talked a little bit about hybrid, but no, the other piece of this is now hydrogen. How will hydrogen work? And that's one of the things working with the National Fire Protection Association we're paying very close attention to, because there is a tremendous amount of hydrogen out there today. You go to any warehouse that Amazon owns, most of their apparatus in the warehouse, the forklifts, are all hydrogen powered. There's a lot of hydrogen being used in agriculture, in buses and things like that. So it's out there. It's how do we harness it and do it safely in the aviation world? So if Steve, if you come up. Now we'll go ahead and move through. You're the last speaker of the day. Well, thank you, sir. Greatly appreciate you being here.
Well, hello, everyone. While they're getting the presentation up, this presentation was jointly developed by Dr. Bruce Holmes and myself. Bruce was originally going to give this presentation, and he had a conflict, so I'm a substitute. But Bruce and I have known each other for almost 30 years. And that 30 years started with a thing called personal air transportation and AGAT. How many people have ever heard of AGAT in here? 1, 2. That's an acronym that it was Advanced General Aviation Transportation Experiment. Came out of Dan Golden, the NASA administrator's vision of a $30,000 GA airplane. At that time, when I was at Beach Aircraft as the head of engineering, we were about $200,000 to $400,000 for the cheapest. And I said, that's not possible without volume. And that was part of our start of the program. So Bruce was the NASA guy, and it was collaboration, just like we just talked about, of a program with industry, the government, and aerospace. We had 70 members, and the estimate after the 5-year program at NASA was that collaboration cut down the TRL time to go from 3 to 4 up to commercialization levels of 7, 8 plus in half. So from the normal 7, 8, 9 years down to 4 or 5. And a couple of examples are the agate composite spec that's now used was developed. That was one of the 5 areas that we looked at. We looked at weather. We looked at how do you get the right information in the cockpit. And at that time, people didn't know the word Garmin. There were 2 guys that came to my office at Beach Aircraft in Wichita looking for money from Raytheon, our mother company. Their names were Gar and Men. They were from King Avionics up in Olathe, Kansas. And they founded this company that we all know very well called Garmin today. We turned them down. Bad decision. It wasn't my decision. It was the corporate decision. Can you go to the next slide, or I'm not sure what happened to the, oh, here it is. What I wanted to start out with was, this is based on perceptions, observations, and some facts. I wasn't sure this late in the day how many people we'd have here to how much we want to personalize it. So I kind of started out with a thought process. Nobody here, I know a few people here, but my background is 50 years in aviation, design and test. I was test pilot, Navy pilot, Marine side. And I ran engineering at Beach. I was a program manager on the Apache. I flew the first Apache helicopter in 1983 as a chief test pilot of the program. And if there's enough time at the end, or maybe later, I'll tell you about one of the small birds, McDonnell Douglas 530F experience I had. And I'm going to start out with a question. How long do you think it takes for a 1,000 kilogram or less helicopter to climb to 20,000 feet? Anybody have any idea? Martin? 30 minutes? Anything any different?
I didn't know they could actually climb that high.
2 good points. Why? Because advancing technology. I'll tell you the rest of the story, but the answer is 6 minutes and 34 seconds. That was a record set. I was by myself in the aircraft. We went to 3 and 6,000 meters, 3 minutes and 15 seconds, to 3 or 10, and 6 minutes and 34 seconds. Now, the other question is, how long did it take me to get down? Well, the aircraft started coming apart at 21,000 feet because the tail rotor didn't like the power settings we'd had. And when I landed, I didn't know it at that time, but 3 of the bolts were going out of the 90-degree gearbox and 1 was stretched. And when it had broken, so to speak, it vibrated so badly at about right at 20, we just passed 6,000 meters, that it pulled the radio out of the Zeus fasteners as I was squeezing the mic to say I'm aborting, which is our pre-brief, because we had noticed some vibrations at 14,000 feet on buildup, but we didn't go any higher than that. And the transponder just kind of came out of the Zeus fasteners too, but I could see some lights on it. So I was clocked 7,600 and 7,700. The ATC was the only people that knew what had happened. My ground crew had no idea what happened. So it took 11 minutes to get to the ground. It was powered as I started turning around, but the vibration was bad enough that at 18,000, the engine quit because it broke the air sense lines on the accumulators and the fuel air mixture got all screwed up. Well, a little bit of a longer story. I can fill you in, there was a lot more to it. But when you're trying something different, we were 50 horsepower over the published limit. We intentionally got as light a weight as we could, like you do for an air show. And we did the flight. And I had a parachute on, and my boss yelled at me after I got to the ground because I didn't jump out. And the question was, why didn't I jump out? I had a parachute. Well, I had always said, I'm only going to jump out if I think I'm going to die if I stay in. And I saw a nice tip path plane out in the sky. So as we do new things, and hopefully as I go through this presentation, I want to leave you with some thoughts about what are the things when you design and when you look at it for safety, for maintainability, for reliability. And there was the best introduction I could ever get is you design it in at the beginning. When you try to put it on afterwards, it costs complexity, it costs money, and it's a real problem. Is it active now? Okay. If you look at this, how many of you would have guessed that in the mid-50s, the Navy lost 770 aircraft in 1 year? And because they were losing so many, even though they didn't cost as much as they do today, you can see the trend in 50 years down to 39 aircraft in 96. And the accident rate, which is generally measured 100,000 per 100,000 flight hours, is down at 1.5 last year in 9 aircraft. Well, if you look at the different items, I'm not going to read it. In fact, there's a lot of things on these charts I won't read. You can look at them later if you're interested at a copy. But you can see that there's some of the things we've been talking about. It was technology, an angle deck. You take off the carrier and you have to eject or the aircraft goes in the water. What happens? A big old aircraft carrier runs right over top of you because it can't turn. It takes a long time to turn. And so the angle deck gave you the ability to not only like you normally turn as you come off the deck, but you were actually being, it gave a double capacity. So you had angle deck and a straight deck, but also on landing and taking off on aborts. So that was the technology. And then some of the things we've been talking about, the safety center or an attitude is what I would say, the maintenance program, which is standardization. And all these came in, why? Because we were in the jet age. It had just been introduced in the 50s. And there were a lot of jet engines that didn't last very long. And that's a lot of the things that we're thinking about as we go through the eVTOLs and electrification and whatever the power source is. How do we eliminate those things and not go through as big a growth curve? Because this is 50 years. Well, I think technology will help us get there faster. But that's a long time and a lot of deaths out of that. And I had an interesting sidelight. I had a guy who did develop the ejection seat for Lockheed Martin, Tony Levere. We had a discussion about the ejection seat. We were looking for one on the LHX program when I was at McDonnell Douglas Helicopters. And he said, you got a challenge there. And that's been discussed here a little bit today, is that all these guys are World War II pilots, Korean pilots. They're not going to ride around with a bunch of dynamite under their rear end and pull it. They're going to dead stick it because they know how. And yet you won't find a combat aircraft today or somebody wanting to take off the carrier without an injection seat functional, because it has saved lives, not necessarily aircraft, but it saved lives. So with that, we've also talked about this, and these are actually intended as setting the foundation for what I'm really going to talk about. I was a CEO and helped found Alakai, if you've heard of it. It was a multi-rotor hydrogen-powered aircraft. I was a CEO and I was also our remote pilot. So I can say, and we've said it publicly, that I've flown it remotely on hydrogen, 4,000 pound or so aircraft in a tethered hover. Hardest flying I've ever done my whole life, because you got all those rotors all talking to each other while you're developing the flight control system, and you don't have really any database to go back. So I used to tell all of our design team, keep it simple and safe. I changed the KISS from stupid, which is why I put the box down there. And I knew we were making progress when we started going through some of our earlier design reviews. Our engineers would stand up and say, and I know, Steve, it's got to pass that KISS principle. And we were looking at how we could make it less complex, purely so that it could be designed correctly. So here's what I'm going to talk about today. And I'll try to tailor it to the time and the fact that it's later in the day. But you can see, okay, so why would you think about hydrogen? Why advanced air mobility? We've heard a lot about advanced air mobility, but we'll talk about that a little bit. And the question was asked earlier, how do we make it equitable? Nancy asked that. You distribute it so that everybody has it available to you, as an example. So why hydrogen in AAM? And then lastly, what are the hurdles? And Bruce and I have been dealing with those for a number of years now. And so as we've looked at this, we've been just collecting data in our company. And so the question is, why? Every time, if you ask the 5 whys, you'll maybe get to the right answer on that. So I'm going to try to give you a couple of thought process for yourself to ask yourself why, and I'll throw out some thoughts as we go through there. But again, you can read all these. We'll touch on each one of these. So this is a DOE chart that shows their goal in the upper left corner. By 2030, $1 per kilogram of hydrogen in a decade. In other words, by 2030. Well, that's making a pretty good jump from where we are today, as we all know. And how do we get to sustainable aviation? We got to look at all aspects of it: the fuel, the airports, and the aircraft. And then from the standpoint of the capabilities, it's a system interdependencies that they've documented here. And I'll say each one of these subsystems, the airport, like we've talked a lot today, and vertiports, and aircraft, all have that same set of system interdependencies within their own subsystem. And this ecosystem really is needed to bring these all together. Otherwise, we just stay with the current system. Why invest billions of dollars if you don't have a good return on it? And obviously the precipitation of that was Uber. Uber said, there's a way to turn what we traditionally have done in aviation into a different kind of market. They finally got the catalyst, and all of a sudden now, whatever it is, over 700 companies are trying to do it. And that was, I think, the real catalyst. But to reduce the cost of hydrogen over 10 years, that's a good challenge. And it takes collaboration. It takes the government investment. And in fact, NREL's hydrogen budget for 2022 has almost $5 billion in there for fuel cells and hydrogen production. So that part of the collaboration is starting to happen. So why hydrogen? Well, the obvious one, air quality. But how many of you realize that we have 15% of the deaths are related to pollution in the world? If you drive into Phoenix when the wind is nice and quiet, coming down from the mountains, Flagstaff, you'll see a nice yellow, brownish level, just like you do in LA, coming down to the basin, where it just accumulates. And we breathe all that stuff. And so that's one of the reasons. And I have to say, in truthfulness, so y'all believe a lot of what I'm saying, I'm not a big environmentalist, even though I believe in hydrogen. I've never been one of those that's gotten on board, but the more I've gotten into it, see what it does for us in the total, it's a great approach. And so for the other reasons, why? Well, we can distribute it. You know, we've talked about the vertiports. How do we get all these different capabilities, whether it's fire support or other things that are infrastructure? But if you can't put the fuel source at the location it's needed, what happens? Your costs just go up. What's the biggest cost of aviation fuel today? Transportation. And if we can use the national pipelines and so forth, which I'll talk about a little bit, that'll help us. And then obviously the reason is it's a national initiative, but it's not just in the US, it's in a lot of other places. I apologize if some of these are redundant for what people have seen before, but hopefully I'll throw out some things you haven't thought about as well. Solar and wind get all of the thoughts about how do you get down to clean energy. They've got their own associated things. Is it offshore? Is it onshore? What geographical location is it? Where is it in the world? Nuclear has its pros and cons, but there's ways to move that out. Pipelines and their distribution set it up differently. So it could go into airports, for example, instead of just substations that distribute it in geographical areas. Those are the kinds of thoughts that need to take place to bring the price down so it's at par with fossils. But it might take a few years. 10 years is a very aggressive goal for that. So why advanced air mobility? I think the simple way to say it is, and I'm going to read a little bit, this is some of Bruce's input as well. The secret ingredient to economic expansion, the lower right corner, without inflation is productivity. That's just a fundamental economic thing. The secret ingredient to economic expansion without environmental damage is some kind of sustainability, meaning we're not having to back up and absorb the cost in whatever method. And then finally, the secret for economic expansion without widening societal gaps, which could be because of wealth, could be because of geography, is the access to that transportation. And if you look at the middle chart, that's what that is. Just look, using the US, we're the best example with over 5,000 airports all over the US that aren't used. I mean, we kind of briefly touched on that today. If simply the first step towards vertiports was that everybody used those 5,000 airports for all of the new aircraft, and I'm going to talk a little bit about how we could use that together with other assets. Just think how the public's perception of airports would change. If you do studies, we did some, I had an air taxi company with 25 Cirruses flying in the Southeast. Most people that didn't want to fly in a small aircraft that happened to have a parachute, when they flew it, they didn't realize that they had an airport within 20 minutes. Dallas is a great example, about 50 of them, within 50 miles of the center of Dallas and Fort Worth. Atlanta, 25. And we get people calling and ask us for a flight and say, well, I only live 20 minutes from Atlanta, from Hartsville. And we said, well, you're in North Atlanta. We'll pick you up at such and such. Oh, I know about that airport. I've never been there. Can you really do that? And I think the VTOL community is going to see that if we can use this sustainable, the distributed air connectivity as a starting point. And again, it's not going to happen overnight, but those exist today. And they exist with a lot of the things, but they don't exist with things for electrification or for hydrogen. We're here because of the change that we're seeing in design. What's traditionally been the way we design? You have a tube, you have a wing on the top or the bottom. You have whatever the newest engine technology drives changes. You stop and think about it. The piston engine came in, got us as it grew, and then turbocharged engines. And then the turbojet engine came in, but it was loud, burned a lot of fuel. They didn't last very well. And the turbofan, turbo shaft of the late 50s and early 60s changed aviation as we know it. That's where we got all of our general aviation aircraft. That's where we got our corporate aviation. And particularly, that's where we got our helicopters. Because all of a sudden, the training aircraft for the Navy, the TH-57, was able to take a 300 horsepower engine and make it small enough that Bell got where you could fly 4 people in it. And it was reliable enough to be a good trainer. And distributed electrical propulsion has given us abilities to get rid of control surfaces in many respects and change the way we design the aircraft. So we've shifted to the neo-electric evolution right now because of that. And these propulsion methods that we're engaging in to support it can be fossil fuel, but it's got other issues there. So why do we want hydrogen? And I'm not here to criticize any batteries at all, because it's going to be a part of a segmented market as we grow. But I believe the numbers are that the battery market is capable of getting us with eVTOLs to about 100 billion out of $1 trillion market. The rest of it is the airlines, the regionals, and the other things that we need to do to make it mass acceptance. This chart you can see in the lower right corner is cost of operation for hydrogen. And you can see where it gets lower, and that's just comparing a piston for a regional. That's a DOE comparison. But all the physics of it says that you get 2 to 3 times either the endurance or payload of some combination with hydrogen compared to the battery. And it's different for fossil fuels. And you're able to, by distributing it, and the chart in the middle is talking about the distribution of all those airports where you don't have to have quite a long a range, but you still need to get enough range if you're not going urban. I mean, if you're going city to city, like the chart that Nancy used this morning, you've got to have several different combinations. And hydrogen allows you to fly within the city and more in the urban areas. And as Zero Avia is doing, now in the regionals start to move the greater distances. And they are, as I think you all know, using hydrogen electrical propulsion, hydrogen powered. And for some of you, you may have seen this before, but just real quickly look at it. This is the energy density that hydrogen has, which is significantly more than batteries. And it's a little bit higher volume density, the axis on the left. But this is where the 3 times the energy, it's 142 joules in theory, compared to what you get out of more traditional fuels that are in the 40 millijoules. But obviously, we're all used to fossil fuels up there, where we've got a nice combination of energy and volumetric density, as shown by the middle part of the chart. But in the long run, what we're doing is looking at a trade, which I'm going to show you in another chart, of payload and endurance for the inherent weight we got to put in the aircraft just to simply carry. How much energy do we need to go for that trip? The heavier we make the aircraft, the more energy it takes just to take off with no payload. And comparison to volumetric density of gaseous hydrogen at atmospheric pressure is a little less than 1/10 of a kilogram per meter cubed. And in liquid form, and at 23 degrees Kelvin, which is the liquid hydrogen, it's 71 kilograms per meter. So that's why the interest in having liquid hydrogen versus gaseous hydrogen at 700 or 350 millibar, and at atmospheric pressure, it's really not a good thing to be doing. And this is the fundamentals. The batteries were the best they're going to do. They're never going to achieve what hydrogen gets to. And the important thing on this chart is if you look at this over on the right side, where a kilogram weight of a battery gives you 5% energy, but 95% dead weight. And currently, if the reference is a kilogram of jet fuel is the 100% reference, with hydrogen, you can get 300% for that same kilogram. That's where the interest in the hydrogen is. When I stopped working at Alakai, even though I still have ownership in the company, I said, what's the real, we were having weight challenges as the whole battery electric propulsion business really is. And I said, so what are the trends? So I went to publicly available charts, whether it was Business Commercial Aviation or AvWeek or whatever, or even some of the manuals, and said, what is the percentage of gross weight? These three lines represent percentage of the operating empty weight, which is everybody but cargo and pilot. What is the fuel load out of that gross weight? And what is the payload? And you can see the trends stick with the size aircraft you have as you move from fixed wing through the corporate aviation side. You can see it's about 20% is the payload. And then as you get into corporate, it changes a little bit. But all of those, you can see what's happening is the operating empty weight is going up. In other words, we're not getting the economies of scale you get with an airliner. And then as you go into the helicopters in the middle there, from light to heavy helicopters, you see the payload goes down and the fuel stays fairly constant. But what's happening? They're just, again, increasing the gross weight in the red line. And then you get to where we are today. And I just picked three and this was a couple of years ago. So Lilium just happened to be there, not because we were in this meeting. And you see the green goes down where you're carrying all that energy, as I said earlier, in your empty weight. And only in hydrogen are you carrying a little bit of renewable, if you would, as opposed to having to take it out and charge it. So on the right side, you'll see a family of four, which is a traditional personal transportation air taxi, what you'd like to have. And if you have a pilot, you need probably closer to 1,200 pounds with cargo, with the baggage and so forth. It used to be 175 pounds per person. We've all gotten a little bit bigger in the US and the cargo. And an EMS configuration for helicopters is about 1,200 pounds. So you sort of need something in that range. And so if you now back in from that to what does that mean for what we're designing today, is if it's the low side, where you're 30% or so on the blue line there for helicopters, then that weight is going to be in the 3,500 pound range, let's say. And if you go down to where the airlines and the GA airplanes are, if it gets as good as 20%, then you're going to be up at 6,000 pounds. So that tells us that to carry that number of people, unless there's a technology breakthrough from all these years of aviation, we're going to be in that 3,000 to 6,000 pound range to carry that number of people. Otherwise, you're going to be half the number of people and half the gross weight. And the complexity starts to step in as a factor of how do you make that aircraft fly safely, the smaller you get. To wit, my example of the helicopter with one bolt, holding it on. And by the way, I didn't tell you the reason it failed was one bearing, an elastomeric bearing, was not manufactured properly. But we never would have found it out other than the fact we were flying 50 horsepower over the certified limit for an extended period of time and at altitude where there wasn't much damping for the tail rotor. And so all of a sudden it started hitting the stop. For those of you that don't know how a proton exchange membrane works in a fuel cell, this graphically shows it there. You have the hydrogen on one side that you have to have available. If you have oxygen from the air, then it doesn't work with all the low temp fuel cells because they need pure oxygen. Otherwise, it causes deterioration in the fuel cell. And if you look over on the right side, the light blue and the yellow and the dark gray, that's really the fuel cell, and then you got end blocks. Anybody have any idea how much electricity we get out of the gray to gray in a fuel cell? That's a single fuel cell. Anybody got any idea? The theory is about 1.3 volts, and then temperature and pressure can change that 1.2 to 1.4. But because 50% of the energy goes in heat, and there's a little bit of water going out, you really only get about 0.6. So how do you get 240 kilowatts? You got to put 400 of those fuel cells there. So if you can imagine 400 in a very small scale between the two grays, and then you got to have end plates that hold them in a steady manner where they don't tweak and move, whether it's an aircraft or a ground vehicle, that causes leakage or loss of efficiency. So that's the design challenge there. The next design challenge is in the powertrain efficiency. And Bruce Holmes ran all the aero for NASA was one of his jobs, PhD in laminar, and especially in laminar flow. So he put together this chart for us that said, okay, what are the inefficiencies? And I won't go through all of them, but you can say at each step, we have that. Well, what does that mean? That just means we need more kilowatts or horsepower. And so it also means in a lot of cases, the complexity adds components. Like the fuel cell support equipment is called balance of plant. And that causes 10% loss, but it causes a lot of additional weight on top of the fuel cells, as an example. And then for doing vertical flight, when we tilt those rotors, we pick up a lot of drag. That's why the hybrids have really, the evolution there with the tilt rotor, all the rotors tilting, and the hybrid has become the right way to go, probably, certainly in the interim, for a longer range. Because what you're doing is using the high power on takeoff, high power on landing, and you're getting way on down for cruise, and you're getting a little bit extra range, a little bit extra endurance. And when we ran some numbers on pure hydrogen, where you just tilt the rotor like you do in a traditional helicopter, you're kind of carrying full power to get any kind of reasonable speed, say 80 to 100 knots. But to do that, you're going to burn a lot of hydrogen. And so you all of a sudden your range starts to come back way back down. So these have to be looked at because of the latent energy and losses that you have. Again, read this. I don't want to spend this, again, because of the time of day, a lot of words there, and this is from DOE, but the bottom line is if you compare the dollars per pax per mile, I ran a quick calculation on that, and it's about, if you do, let's see, the 0.63 on the hydrogen on the far right side of the tilt rotor hybrid, and you run that for 4 passengers for 100 miles, it's about $250 an hour. Works out for an operating cost of a total cost of ownership. Now, there are other costs, obviously, like we talked about. But that's the motivation to go to hydrogen, where you can drop that down. And for those of you that are not as familiar, and Rex, maybe you are from all the fire stuff, hydrogen burns very differently than any kind of aviation fuel. It kind of settles down, or a cart settles down. And that's why we have containment areas on airports, so that it doesn't spread the fire over. If it catches on fire, it keeps it from getting out into the groundwater. But hydrogen, if you have a break or opening, it goes straight vertical at about 45 miles an hour. So unless you got something holding it in place, it's gone, it dissipates. And it's got a much wider range of flammability, but it's higher than what we traditionally think about. It's got to have a spark, it's got to have the oxygen, and just like traditional burning. So I've seen studies, and I personally believe that it's as safe as any other hazardous material that we have in aviation. And one of the biggest challenges for us as an industry is to get the education that it's not a Hindenburg. Because that wasn't the reason the Hindenburg burned anyway, you know, but that's a perception. And so we've got to get rid of that. So what are the hurdles to market? The TRL levels, I'm going to speak about that a little bit more. And as I mentioned, the collaboration, which has been talked about a couple of times, Bruce and I strongly believe that's the only way we're going to accelerate getting the hydrogen TRLs to levels where they can be commercially viable and a high volume. These lower charts explain a little bit about that and what the different technology readiness levels. I have another chart I want to show you on that. But we've got to get the weight down. And that's that powertrain reduction. And that's technology in the fuel cells, in the end plates. But just as importantly, it's in the fuel tanks themselves. If you put a 350 bar tank in there, it's really heavy. It's not as heavy as a 700 bar one, but it's not quite as heavy as the liquid tanks. But the liquid tanks have a problem with boil off. They can't, like if you parked a personal hydrogen powered air vehicle in your driveway and then drive it for 2 weeks, about half of it would boil off by today's accepted standards. How many people, what's the largest user of hydrogen in the United States? Who's the largest user? Anybody? Mike? They are today. Yeah, they are today. But it was NASA. And that big, gigantic thing they have down there that they bring in the hydrogen right before the launches by truck, which makes it really expensive. And blow up's a big deal. They put a lot of research into it, but it's not really applicable to air vehicles and certainly not the size we're talking about. So that's the type of technology we need, development. In fact, there's a ULI going out right now that Boeing, University of Maryland, a company called GTL out of Tullahoma are all on it. And Bruce and I happen to be on that ULI, trying to figure out how do we get those liquid tanks at a weight ratio where the hydrogen you can carry and the weight of the tank's not so high. And they've had a breakthrough with some NASA contracts where they're up in the 50, 60% range, which is far, far beyond anything else. But they're expensive right now and there's no volume. So this chart I put in here, again, this is a perception by a lot of people about where we are. The hybrid and batteries are about ready to jump into commercial use. If you look at the one that's right out beside 7 there, and this is for larger man versions. I need to clarify that. A lot of drones flying hydrogen today, some of them 5 to 10 hours with small payloads, less than 55 pounds. But to get the things that are needed in vertical aircraft or even in hybrid with hydrogen, the electric motors need to be improved. Some people will say they're there today, but I think they need to be improved because we're operating them at the wrong efficiency range. And the liquid tanks, again, is a problem. The fuel cells I mentioned earlier. And then finally, when you get 50% heat coming out of a fuel cell and you've got to take the liquid hydrogen and take it to gas so you can put it in a fuel cell to use it, you got a big heat exchange of heat and coal there. So there's some studies taking place right now about how do you make that more efficient? How do you maybe put that in the HVAC system for the vehicle? I mean, that's a natural thing. So that has not been traditionally what it's been thought about. I mean, you know, the bleed air off of the Hawkers that we were building in Beach or even our King Airs, there's a lot of heat coming in there that we had to cool off before it went to warm up the pastures at 30,000 feet. These are technology levels, and if you look up on the right for the goals of cost, durability, and efficiency, and the timeline, this moving from a TRL 4 to 5, which is where Bruce and I personally think that most of these technologies for hydrogen are located, could be 7 or 8 years. But we're strong advocates for the collaboration to get that reduced, again, like we saw in agate. This is DOE showing the other part of the equation is you got to have the hydrogen where you need it. And it's no different than having charging ports at any location. So a natural place, I think, is to start as the airports. But this is currently where the production facilities are. And you can imagine, unless you're in a pipeline, moving that all over the United States is a lot of cost of the transportation of a truck. So maybe there's a better way to do that. And the other part of this is how much do we really need in the U.S.? I remember, and Rex, I don't know if you were there, but the Uber Elevate in Los Angeles, the public works director for LA said to the conference, the amount of electrification you guys are talking about that's needed to charge the full per hour rate is equal to the current grid, and we're getting brownouts. So that's an infrastructure problem. And without that, we can have all the greatest vehicles we want, whether they're hydrogen, battery, doesn't matter. But if that infrastructure is not there, which this shows a roadmap that DOE is looking at, how do we do that? Not just for the environment, but how do we do that for the cost, and how do we get it for the equity of moving it to places that don't have the big airports? And another example that I want to make, if you hadn't thought about it this way, if you think about how we grew computers from central processors to distributed processors, that's how the worldwide net really grew faster than anybody ever thought. Well, the same thing can happen with getting the airports to become the 5,000 one right now in the US, and this could apply worldwide, but to have them be the initial distribution points, if you would, because they're already there. We don't have to go build things. So if we can come up with a way, and I'm going to show you, this is kind of redundant to this particular chart, but it was just simply to show there are pipelines there, and there's research of how do we mix natural gas with hydrogen and ammonia, where they have those pipelines exist and do them like they do with different grades of gasoline today, but there are issues, hydrogen embrittlement as an example, that have to be studied to do that. But I think this was touched on a little bit today. The Vertical Flight Society has a group working on airport, hydrogen in airports right now. Recommend you go to the website if you want to join that. It's been going on for about a year now, I think it is, Mike. We've been talking about what are the challenges. Ironically, this is a DOE chart, but I want to claim some ownership that Bruce and I came up with this about 3 or 4 years ago, that why not use an airport that exists to both let electric cars come in there to the edge of it, not necessarily inside the fence. Hydrogen cars use the hydrogen outside the fence, use the hydrogen inside. It's being used for GSE on some airports like Logan in Boston right now. As mentioned earlier, Amazon, Walmart, they use a lot of hydrogen for their vehicles, their forklifts inside of their major buildings right now for cooling on major, the big servers like are here in Texas, are reasons that we need to use the current infrastructure we have to maximize that. So again, we looked at this and said, well, if we can get the stationary power, in other words, some hydrogen generation on site at the airport, we already have the airports that are more protected than the normal, like a service station. And if that can become a source of both electricity and hydrogen, then at the bigger airports, you get a large volume of usage with the large airports. You got all the current GSE, you got the big truckers and the buses coming by there and stopping. That's a way to get volume sooner. But again, you got defined locations today that can be looked at by the regulations differently, because airports have regulations today that address hazardous materials, operations, training, safety, maintenance. This is another DOE chart that I thought would be interesting. If you look up on the right, the chart says the red is low volume. In other words, currently, what are these costs of fuel cells? It says R&D, but what is the cost per kilowatt? It depends upon what company you're talking about in the world. The production cost, the delivery and dispensing cost, and onboard storage cost. And the middle is if we raise it to high volume. And when we were doing the agate program, the Williams founder came in with an engine underneath his arm to Dan Golden to one of our visits. And it was the lead-in engines that got to the FJ series, if you're familiar with the 44 series in the light jets. And he was carrying the engine under his arm. He had developed it off of the cruise missile engines that Williams engines had done. And as we walked in, I was walking with Sam, I'm sorry, I said the name wrong earlier. Sam Williams, Dan Golden, the NASA administrator, said, "Are you guys going upstairs to the meeting right now?" "Yeah." And he said, "What's that?" And he said, "This is the engine that you're going to give me a funding." He got a large NASA funding for it. And he said, "Well, what's it going to cost per engine? How do we get it down to $50,000 per engine?" And this is when the Pratt engines were 300 plus or minus. He said, "Volume. I need to be getting at least 10 or 20 or 50,000. And he said, that'll come through the personal air transportation system that today we'll call it AAM or UAM. You can see the aggressive goals of where we got to get down there. You saw, I mentioned the goal earlier, $1 per kilogram. But if we don't get down to these other goals, it'll just delay until the technology will break through. So what are the takeaways? Again, I'll let you read those. But the important thing is the hydrogen exists today. It's, it's abundant in the U.S. We're not going to run out of it. And the way we produce it is you make water as a byproduct, and the electrons get put back together, and we gain that benefit. So it is a totally renewable asset. So that makes it a good end-to-end clean energy. We did some calculations that 99% of the things that are related to hydrogen are renewable. And on the fuel cells themselves, it's about 95% are renewable. 5% you got to get rid of, as opposed to where a lot of the technology in batteries today is looking at, how do we dispose of them? How do we come up with better technology? And I know one of the founders, not Elon, himself of Tesla is looking at that as a technology breakthrough. He's going to take things like that to keep this moving. And again, y'all are pretty familiar with AAM. Well, I mentioned the three aspects: the sustainability, the accessibility, and productivity. That's what's going to make it go forward. And how's it going to go forward? With high volume and mass acceptance. Without that, it'll just be another one of those acronyms that we all worked on for 5 or 10 years and it never happened, like the VLJs. How many people know what a VLJ is?
Very light jet.
Yeah, very light jet, but look, not everybody knows because it was in the 90s and early 2000s. And it was the coming thing. It was going to replace all aviation, and it didn't. And then finally, what are those hurdles? I believe the biggest hurdle is education. I mean, it's infrastructure, but it's education of all the people we've talked about today. It's education of the local communities. It's the state level. And I think as we get that education out there, what will happen is it's no longer the technology that we've been working on. It's the market pull, because people say, look at all these benefits to me. I can go 20 minutes, and I use Atlanta because I'm from South Carolina, if y'all can't tell. I don't have to drive into Atlanta and fight all that traffic. I just go to the closest airport, and either I take one of the VTOLs over to Hartsville, and we get intermodal transportation, or I take a regional, depending upon where I want to go. Or maybe I just expand my market for my company by going to a place that has a little uncontrolled airport that's never used from where all the economic centers are. And why are the economic centers as big as they are? Because everybody came there to get the money. And so the transportation systems evolved, and all the intermodal transportation all crosses those sections. And I'm a little biased because of my time at Beach, but the King Air expanded the market in the Southeast for the textile industry. It was because all of a sudden the interstates weren't developed, but people could go and visit all their textile plants in a day instead of driving for a week to go to all those places. Now, this last one, again, I'm not going to go through all these. I'm just going to highlight a couple of them. Interesting to read. The fact that Texas will become the largest green hydrogen plant very shortly, I think is significant. Previously, Japan had it. The Hydrogen Council, look at the people that are on there. They're major players. And that says we're interested in this because of the potential that it has. And we're investing in it. When you see Shell and Hyundai, and we're all familiar with what they're doing right now in aviation, but Toyota, partnering with Joby, for example, some of the engine guys, and the fact that there are 52,000 forklifts, which is moving a third of the food in the U.S. That's factors that you really don't recognize. And then lastly, NASA is still the world's largest user of hydrogen until, as Mike said, Plug started getting their distribution networks and so forth, and they're doing a great job. So I think that the main drivers for hydrogen coming in are TRL levels, dollars per kilowatt, kilowatts per kilogram. These are just metrics. Dollars per kilogram, the availability of that hydrogen, as well as the availability of the fuel cell materials to put them together. Same problem that batteries have. And finally, education. So with that, I'll thank you. And I'm not sure how we did on time. I wasn't paying attention, Rex.
Great discussion, Steve. It's fantastic to listen to this next generation of technology that we're looking at in conjunction with electricity and batteries and everything else. I'll ask real quick, does anybody have any questions for Steve before we wrap up today?
This is kind of off the wall, but I was able to participate in some space ballooning, if you know what that is.
Mm-hmm.
And so we were using helium because of the hydrogen danger. And we actually did have a balloon explode, a hydrogen balloon. And sometimes when we were picking up really heavy things like the SpaceX capsule to do drop tests, we had to use hydrogen. We had these massive safety protocols that we didn't have with helium. And you just said that The Hindenburg was not burning because of hydrogen. That's the first time I've had ever heard that.
It was a doping around it. It started the fire, electrostatic discharge on the doping,
Right.
and then ultimately it burned. Well, all hydrogen materials are going to burn. That's why I'm saying everybody sees a big explosion and thinks that's what's going to happen.
Okay.
It will ultimately, obviously, if you get the right temperature of ignition and oxygen mixture.
Right. So the liquid is a lot safer than the gas.
I'm sorry?
Is the liquid a lot safer than the gas? The liquid format?
I wouldn't necessarily say that. It's contained, but it's going to turn to gas as soon as it goes in the air.
Right.
And it's just going to go vertical.
Okay. I guess when it's being stored, it's liquid. Like, so if it's on the aircraft,
Yeah, it
it's
has.
in a liquid state.
There's typically a stainless steel today, and that's where a lot of the technology is taking place. It holds it inside of a dealer that has the outside, which is a lot of times composites or other things on the outside. And then you have piping and so forth that takes it, keeps it liquid until the point at which it needs to be converted to gas.
Thanks. Great presentation. Thank you.
Thank you.
Mr. Mike?
Thank you. Steve, great talk. Really, I think covered a lot of the bases. And so Mike Hirschberg, Vertical Flight Society. So, VFS in 2013, we saw electric VTOL, was a coming thing. And we would tell people, there's 1,000 reasons why this won't work, but we're going to try and work together to find all the, the solutions that do work. And we're kind of there now with hydrogen, where there's a lot of challenges, technological and infrastructure and all sorts of things. But it's really exciting to see the potential for hydrogen. I think also that all these challenges can be overcome and have a really exciting new, much greater energy density and potentially, completely green and things. Steve mentioned there is this, we've been working on hydrogen for several years. We're working on this white paper. If you're interested in joining our efforts, so we have actually 2 working groups, but go to VTOL.org/hydrogen. That's some basic information about what we're doing on hydrogen. It's some really exciting stuff. We had, so the Vertical Flight Society, so we used to be the American Helicopter Society. In this past March, we had the first conference in North America on hydrogen for aviation. So it's just mind-boggling, but it's such a game changer, or has such potential for vertical flight. And appreciate your insights and coming here. And again, just want to invite everybody who has an interest in this and to try and overcome a lot of these challenges to look at the website and please join one of the working groups.
And I would add to that again, I think that the batteries as they are today, and unless we have a technology breakthrough, there's a limit to how far they can go in the payload. And so it's going to leave a gap there. And the hydrogen is really going to be the accelerator. So the technology work that needs to take place, that I will say, not everybody agrees with me that is trying to sell hydrogen VTOLs probably, but I'll say from my personal experience, it's going to be a few years before we get to the point where it's where we need it to be. But that acceleration past that 10-year mark is going to come from hydrogen. It's not going to come from our current technology in batteries, in my opinion.
Well, thanks, Steve. Greatly appreciate that. I hope this has been informative. We've had people come and go all day. I think we were up to almost 40 in this room at one point, and then I think lunch happened and we lost a few, but I raise of hands. Was there good information out of this that you enjoyed? Learned some new things? Good. That's what we're trying to do. Hopefully, looking at this going forward, also, we're looking for collaboration. That's the key to making this work. So if there's information that we need to get out to everybody in the collaborative area, please don't hesitate. We have something online. Hey, awesome. Stand by, Steve.
And if it's Bruce Holmes, just tell him, thank you.
Just hang up, right? All right. Bear with me. What ASTM standard is being developed to type certify hydrogen for fuel cells? Any,
I don't know, Mike, do you know it off the top of your head? I don't know what it is. I don't know the number.
SAE? Okay.
As I understand it, SAE has a number of standards for airport. I mean, obviously for automotive, there's lots of SAE standards, and they developed several for airports. And the work that we're doing on the hydrogen, the H2 era team is looking at informing people on getting more familiarity with the fuel cells and everything, and basically providing the basis to form standards from that. So whoever asked that question, join our working group.
Yeah. What I can say is that the ones for the ground vehicles are basically what existed 5 years ago. And when we had our first meeting, I think we were the first hydrogen company to meet with the FAA. They asked us, help educate us, which is the way you want to collaborate too, on what these fuel cells mean. We had to do sub meetings to explain it. A lot of people didn't even have any comprehension about how it worked. And so that was the challenge in getting knowledgeable aviation people about hydrogen. They could then look at an AS type spec and put it in the right thing. Because the worst thing you want to do is have people with perceptions that aren't accurate. We're all entitled to our perceptions and opinions, but if they don't ultimately end up with the right factual information, we take ourselves down the wrong path. And I'm sorry, I was going to end with this. There were a lot of people back in 1900 that believed you're not going to replace the horse, and they had every reason in the world not to put a dadgum car on the street and scaring everybody. And it wasn't until Henry Ford made some of the breakthroughs that he did with production, and we got electric starters and pneumatic tires. And all of a sudden, and I credit Bruce Holmes with this, the number of license applications in the United States went up just exponentially. That was about 1917. But it took those 2-3 events after cars were starting to get in production. But for 10 years, a lot of people were saying, this will never happen. Why would I want to get rid of my horse and buggy? Why do I want to ride a car? It makes all that noise. It scares me. And I think we're in that same time period of not just hydrogen, but for the whole eVTOL, all the stuff we're talking about here.
No, and on the standard side, the other standard I would point to is NFPA 2. NFPA 2 is a hydrogen standard, primarily for the fire safety side.
And for storage too, right?
Right, storage and production. So that's a standard. ASTM, I'll have to look that up and I'll find out.
So when we put our liquid at our airport, what took us the longest was the local fire people, the education, writing what they needed, modifying what they needed. And we worked with a group that I would advocate anybody looking at hydrogen is ARUP. They're an international company and they do a fantastic job of helping walk through those type of regulations. Because most of us aren't familiar with it. We've been living with current fossil fuel type ones for our whole lives.
Thanks, Steve. Greatly appreciate it. So that ends our discussion for today on advanced air mobility as it relates to safety specifically. But like I said, anybody has any questions, don't hesitate to reach out. Mike and I are here all week for the Vertical Flight Society, also with the HAI. With that, I'll go ahead and close out. Thank you very much. Have a great afternoon, and we'll see you tomorrow. We'll all be back together tomorrow.